Hopefully my screen is visible.
Yeah, it's visible, sir.
We will be doing 2023 September paper. So I have the afternoon and the forenoon paper. So
already done this, right, Chad?
No, this paper we have not done. We have done 2022 September paper. So this is the 2023. So basically we have done these.
Okay.
So we have done 2023 May and Jan, and we have done 2022 September and May. So today we'll do 2023 September. Actually, this paper we were not able to find earlier in most websites, but now that we have got the paper, so let's also go through this. So let's just start with one of the papers, and then we'll do the other one after that. So let's start with this paper.
Which one?
So,
AN, is it?
Yeah, this is the AN paper.
It's December 24th paper, right?
Yeah, December 24th, 2023.
Yeah. Go ahead, sir.
All right. So here the first question is, the following command is run in the terminal. Which statement are true of the options given below? So here the command is grep -xff. So this is capital F, this is lowercase f. And then we have less than symbol, and then in round brackets sort file1, and then file2. And then the entire output of this is pipe to sort, and then pipe to unique. Right. So does anyone remember what does grep xff with two files do? So X basically means match the whole lines. Capital F means it will treat the pattern file as it will treat the pattern file as fixed strings and not any regex. And lowercase f basically means that instead of reading the pattern from my argument that I'm providing, you should read the pattern from a file that I'm providing. Right. So basically, if I have here, let's say, a file which is fruits, and here I have a few fruits, and here I can also open even. So here, if I want to find all the fruits that have the letter E, what I can do is I can do grep E on the fruits, and it will print only those lines that have E. But what I can also do is I can create another file called pattern, and here I can simply write E. So this is the pattern that I want to search for. And here I can do grep -f pattern on the fruits. This and this are the exact same thing. But now, because we have a file, we can also give multiple patterns. So I can tell either the line should have E, or the line should have the like sequence A and A. So now, as you can see, both like any line which matches any of these patterns is printed. So for apple and cherry, the E's are the match, whereas for banana, A and A is the match. So this way we can use -f to give a pattern file. So here we can also use regex. So for example, I can do A and then any letter and then A. Right? So this will still match the A and A in the banana, because dot can match any character. But if I am using it this way, so here regex works. But here, if I now use capital F, then I'm asking grep to treat this patterns as like fixed string and not any regex. So this is searching for a literal dot in the file. So now that will not be matched, only the E's are matched. So if I actually change the real file and put a dot there, then it will be matched and printed. But otherwise, it will not match. So that is what the F and F does. And the X will just ask it to match the entire line. So only if what I've written here matches the entire line, then only it is printed. So here, if instead of this, if I give a X, then right now nothing is printed. But now instead of A dot A, if I put banana here, so then you can see only this is printed. So only patterns that are matched literally and present as the entire line that are printed. So what does this command basically do? So we had discussed this earlier. So this will basically print the lines that is common to both the files, right? So lines present in pattern file and lines present in fruits file as well. Because we are not treating this as regex, and we are also asking the entire line to be matched as the entire line and not as a substring. So this simply prints line that is common between two files. Now here we also have this process substitution. So here what we are doing is we are running a process. So this is going to run the sort file1 command, and the output of that is stored temporarily as a temporary file or a pseudo file. So it's not a real file, but a FIFO file or first in first out file. And for grep, this will simply look like a file, so it can just read line by line. And then what this is basically doing is it is printing the lines that is common to both file1 and to the output of this command. So the output of sort file1 is simply again still the lines of file1 itself. So the order might be different, but the lines of the output of sort file1 is same as the lines of file1, may or may not be in different order. So then when we are running this is basically doing the same as grep minus xff file1 file2. So we're simply printing the lines that is common to both file1 and file2. And after that, we are simply again sorting the output, and then we are removing if there is any duplicates. Right. So in general, what this line command will do is it will print all those lines that are present in both the file of file1 and file2. Right. So we can also test it out. So let me create maybe a few other lines here. And instead of patterns, so let me remove the patterns file and let me create a colors file. So you can see now we have one line which is common in both fruits and colors, which is the orange. So now if I run this grep minus xff sort file1, let's say it is fruits, and file2, which is let's say colors. So this will simply give you the same output as if we just write fruits and colors. Right? So the lines that is common to both. And then if we pass it to sort and unique, so obviously if there is no duplicates, then we will get the same thing. But if let's say in the single file itself we have a duplicate, so the orange is present 2 times, then this will so if we are giving the fruits as first, then it will only print it once. But if we are giving the fruits as the file itself, then it will print it 2 times. Right? Because if it is treated as pattern, then a pattern can be present 2 times. It will not change anything. Whereas if it is treated as the file, then if a line is present 2 times in a file, both of them are printed. So in either case, if a line is present 2 times, if we do sort and unique, then the duplicates are now removed. So now we only have single occurrences of all the lines that are present in both the files, file1 and file2. So that is what this command. Yeah.
How would have sort helped actually? In this case, it doesn't do anything, right?
So in this case, yeah, it will not do anything. So this is basically to see whether you understand how this works. So because one of the options here is that this is a syntactically incorrect and it will throw an error. Right. So if you think that will throw an error, then that would have been a wrong option. So this is not helping, but this is also not changing the output. So the output remains the same. Maybe the order of the output will be different. Because actually no, so the order of the output depends on the order of the lines in file2 or the actual file and not in the pattern file. So sorting file1 will not make any changes. If file2 was sorted, then maybe some change would have been there. And then again, sorting it basically just changes the order of the output. So that may or may not be same as not sorting, as we saw, like the unique might be required in cases that there is a duplicate. So the output here basically represents the one occurrence of all the lines that is present in both the files. But even if we don't do this process substitution and we don't do sort and unique, it will still print those lines which are common in both the files. So it may be printed multiple times if it is present multiple times in the files. But the action done by the grep minus xff is that.
Excuse me, sir.
Yeah.
So the file one is having the sort function, right?
Yeah.
So like what it is doing particularly, sorting the pattern because it's pattern, and we are searching that pattern into the file too, right?
Yes. Yes.
So what sort it will do? Like it will alphabetically arrange?
No, it will not have any effect in this command, because here what we are doing is so when we are running this, right? So this is the command. Sorry, not this.
Also, it is already sorted. That's why it's not working. Suppose mango is in the very top.
Yeah, so even if it is not sorted, so let's say this is present here, right? So still the output will be the same, because what we're doing is the first file given to grep is the pattern file, and the second file is the file in which to search for each of the patterns, right? So what we are doing is we are basically sorting this file, and we are searching if any of the pattern is present in a line. So grep will go line by this file, right? So the file 2. So it will going line by line with this file. So it's checking for the first line if this first line matches any of these patterns. So for first line, it will go through all the patterns and see which pattern matches. So whether this second file is sorted or unsorted, that will not make any difference in the output of grep, because it will basically check line by line for the second file. So wherever the first occurrence of like common line is present in the second file, that will be printed first. So the output of the grep will be dependent on the order of the second file. So sorting or not sorting the first file will not have any effect. But then we have also sorted the output of grep and then done unique. So if there is any duplicates, we are removing them.
Sir, like, then what is the sense of writing the sort in the pattern?
Yeah, right. So this is not doing anything, but this is also not causing any difference. So here, if you see the options, then it is clear why this is given, right? So here we have an option that the command will fail due to the wrong implementation of process substitution. So if you are not familiar with how FIFO works or how process substitution works, and if you think that this will basically cause the command to give an error, then you will mark this incorrect option. Right, so this is not helping, but this is also not doing anything. So this is basically a redundant thing that is added, but this is to test whether you understand how this command is working.
Okay.
Right? Okay. So the first one, the first option given here is also like required for you to understand. So if this option tests whether you understand how process substitution works. So the first option is the sort file1.txt, which is this inner part, will be executed first and provide sorted input to the grep. So that is true. So first, this inner part is basically run so that this file1.txt is sorted, and then its output is basically fed by line to grep as the patterns file. So first, this will be sorted, and then basically the sorted output of this and the file 2, it will be compared by grep which lines are common in both. So the first option is correct. Then the second option is basically what the command is doing in general. So the grep will try to find a match to each line from the process substitution's output with file 2. So any line that matches both the file 2 and the output of the process substitution, which is this one. So the lines that match both will be printed to the screen. So that is what the...
Shad, what is process substitution? Sorry.
So this basically, this way of running a command and then using the output of that command as a file, basically a temporary file, is process substitution.
Okay.
And there is this hint at the bottom.
Yeah.
How do we interpret that?
So the hint basically shows that if you simply run seq5, then you will get this output 1, 2, 3, 4, 5. So now you can run grep and then in brackets 2, 3. So this is regex, which means either 2 or 3. So if you run grep with this pattern on not a file, but on this process substitution, right? So you can basically run a command and treat it as if the output of that command is a file, a temporary file.
Okay.
So you can run grep on that. And if you are searching for the number 2 or 3, then out of this output, the grep will print only 2 or 3. So the hint, like the comment also mentions that the command output stored in temporary file, and that file path is substituted in place of the actual thing. And so we have also seen this in one of the previous papers, I think May of the same year. And so hopefully this is clear how this command works.
Yeah.
And the command is correct, and it will produce the common lines in file1 and the file2.txt, right? Because sorting will not make any difference in the output. So let's move to the next one. So in this question, we are told to select the commands that retrieve the first 10 lines of all the files that end with a .md. So all the markdown files in the current directory and its subfolders. So this question I think we have done in some
OPP,
other other PYQ? Was it there in OPP?
Yeah, it was there in my OPP.
Okay, okay. So I remember discussing this question.
So this is already in previous paper also.
Yeah, so it was there in the previous year also. So basically, if you want to find files not just in the current directory but also in the subdirectories, then which command do we use?
Sorry.
So basically, if I want to find files which are not just in my current directory, so I can simply do
ls minus lr.
Yeah, you can use ls minus r, but then the output will also have like the name of the folders and indentations. So which is a better command to like recursively find files? If I want to just find a file, maybe with a name.
Find command.
Yeah, exactly. So the find command is more suited for that. So what we can do is we can let me just create a folder like that. So maybe we can have a few files and a few markdown files. And let me create a few folders. And in those folders, let me also create a few markdown files. Right, so right now we have a structure like this. So we have a few text files, a few markdown files, and a few folders inside which we also have a few markdown files. Right. So if I want to find just the files and not the folders, what do we use in find?
Type.
Minus type.
Type F, right? F. So fine. So yeah. So now we can get only the excuse me. We can get only the files here. So how can I also restrict that the file name ends with
star dot?
We can type it, no?
Yes.
Star.md.
Yes. So without piping, how can I do it in find? Like what argument do we use? Like
Star.md won't work. Type.
No, if you do star.md here, so it will only glob the .md files in the current directory, right? And anyway, find expects a directory and not a file. So you need to mention that to find.
Name.
Yeah. Yeah. So you have to use the name command, sorry, the name flag. And here, if you mention star.md, then it will only list out those files that have md at the end.
So what is that name?
So name is an argument to find. So if you're using the name argument and you give, if you're using the name flag and you're using an argument to it, so it will only list out those files whose name matches this pattern.
So you were saying before writing the name, you were saying that it will print only directories, or it will, what was
No,
that?
so we are using type F, so it will print only files. If you're using type D, then it will print only directories. So here we are printing only files which have star.md. And if I also create another file, let's say z.md.txt, right? So this find type f name star.md, will this print this also?
What is markdown files means, sir?
So markdown is just a type of file, so where we can like format the text, like add headings, etc.
Like
it will find, I think.
Okay. Okay. So why is that?
Because it's looking for that .md is there in that file extension.
Okay. So basically here we are using like globbing, but it is not like regex. So glob in general will not match substrings by default. Oh. So if we want substrings, we have to deliberately put a star here. So another thing to note is that we are not using dot star, which is the syntax for regex. We are only using star, so which is what we do in the shell globbing. So here star means any character any number of times, and dot can directly be used unescaped to mean the literal dot symbol. If I use star.md star, then we will get this one which has .md in the middle. But if we don't do that, then we will only get those files which have .md in the end. So we should do this because we want only files that are ending with .md. So now that we have all the like files that are the MD files, how do I now print the first 10 lines? So we have to print the first 10 line of each of these files.
We have to cat through each one and
Head.
or head.
Yeah, so head will print the first 10 lines of each file. But how do I give each like file name to head?
Yeah, exargs
EXE.
or exec.
EXE or exargs.
Yes, you can use exec or you can use like you can pipe this to exargs. If you pipe this to exargs and you type head, so what exargs will do is it will call head one time with all of these lines as arguments. So it will call head F, E, G, H, everything in one line. So it will just run head once.
I think there was some flag called -LL or something like that with
Yes,
exargs.
yes. So if we do only this, then it will basically run head with all of them together only once. But if I use the -L1, so what this will do is it will run head with only one line at a time. So it will run head with the first one, then it will run head with the next one, then head with the third one. So it will run it one by one. So the only difference, so the output will be the same. The only difference is that if you give multiple files to head, it will also print this like separator and tell what is the name of the file between each file. Whereas if you just give one file to it, it will not print that. So here right now we don't have anything at all. So let me add something maybe. So in the h.md, let me add something. So for the sake of demonstration, I won't be adding in all the files, but basically this will print the first 10 lines of all the files. So if I use the, if I don't use the L1, then also the output will be the same, but we will also just have these extra outputs, which is the separator between each file. And similarly, if we use any other number, also if you use L2 also, then also this will be there. So two of them will be printed together, and then again the next two will be printed together. So you can see this first one and this, there's a space, and then the second one is there. Then again the third one starts, so there's no space. Right, so we can use this to get the first 10 lines of all the MD files.
If you do this L1, we won't have any of those separators.
Yes, exactly. So we can also see that clearly if you're using echo. Right. So if we are using echo, then basically what exargs does is in any command, it will put all the like lines of standard input side by side. You can see everything is put side by side. But if we are using, let's say, L1, then it will only run echo with each of them one by one. So we will basically have echo F, then echo E. So that's why everything is printed in a new line. And if I, let's say, make it 2, then you can see 2 consecutive of them are sent to echo in one run of echo. Then again, the next 2 are sent to echo. So that's why they're printed side by side. So in head, whenever you're giving more than one file, it will automatically have this separator. So that's why with any L value or without this -L also, we get that. But with L1, because we're only sending one file at a time, we don't get the separator. We just get the first 10 lines. So anyway, with or without this, we are getting the desired output of the first 10 lines of all the MD files in the current and subdirectories. We can also use the -exec command, the -exec flag of find to directly do this. So here I can say to run head, and the opening and closing curly braces is just the placeholder where the name of the file will be put. Yeah, sorry.
Sorry. Okay.
Yeah. So this will basically be replaced with the name of the file for each file. So this will always run this way with L1. So we don't have to write L1 here. That is a parameter of exargs. So in find, it will always run it once. So the command will be run with one file at a time. And then we can use backslash and semicolon to basically signify to find that my command has ended. Because our command can have many flags also. So we can keep on writing the command, and we signify that the command has ended by giving this escaped semicolon at the end. Right, so here also you can see it will basically print the first 10 lines. I only have 2 lines, that's why it's only printing that. So let me maybe add other things also. Maybe if I add sec100 to e.md. So then you can see if I run this, only the first 10 line of that is printed. So from 11 to 100 is not printed. Right. And finally, the another thing which we can do is if we simply do this, so just the name of the files are there, and we can just directly give the output of this as the parameters of head. So I can run this, and from the output of this, which is basically this, I can just give it as a parameter of head. So head will get F, E, G, etc. So head is only run once. So it's the same as running exargs without the -L flag, and all of them will be given to the head. So that is possible because head takes multiple files. Right? So if I do man head, we can see that head takes file ... which means it can take as many files as you want. So if you give multiple files, it will print the first 10 lines of all the files. So if we run it this way also, we basically get the first 10 line of each of the files. So in E, you can see only 1 to 10 is printed. In H, the 2 lines are printed. Others are empty, so nothing is printed. Right, so hopefully this is clear how this is working.
Clear.
All right, so let's see the options here. So the first option is the exargs, as we saw. So we can use find. So dot you can or cannot give. So by default, that dot is assumed. Dot means the current directory. So find in the current directory files which are regular files and not directories, and which have the name start.md. And then for all the output, we basically pass it one by one to head. So that is the first option. And the second option is the same thing as the first part, and we are just taking the output of it and directly giving it to head. So this is same as doing this exargs without the -L1. So hopefully these two are clear. And the third one here, we have *md star. So here we saw this is not correct because this will print all lines that have .md anywhere in their name, not just at the end. And in the last one, again, we have, so we have multiple issues here. So first of all, we don't have -type f, we just have type f, which is a wrong syntax. Secondly, what we're doing is from the output of that, we are doing grep md. So this grep md will match a md present anywhere in the line. So we should actually do grep \md$ to match only mds at the end of the lines. And then we are piping it directly to head. So if you simply pipe this to head, what will be printed? If I do find type f, so here we have all the files. Now if I do grep md, we are getting even this one. So instead we should do grep \md$. So now we have only the files ending with md. So if I pipe it to head, what will be the output?
First 10 will be displayed.
Yeah, the first line of this, right? So only like
Path of the
yeah. So we will basically get here till JB. So we will not print the first 10 line of each of the files. We will simply print the first 10 line of whatever is passed. So this thing was passed to head. So just first 10 line for that is printed. So the last option, there is multiple things wrong. So that's why this is not correct. And in second last, this star is wrong. That's why this is not correct. Right, so hopefully this is clear. So let's move on. So in this, we have the following command is executed in the terminal. What will be the output? So we have a date.txt. So you can see the output of that. So cat date.txt has these following. So this is the file date.txt. So we are doing cat date.txt pipe sort pipe tail -1. So what is this doing? This command?
recent model.
This will sort and give the last line. So
yes. So from this file, it will sort it, default sorting, and it will give the last line. So now if we sort this, then what will be the last line?
You'll get the most recent date, I think.
Okay. Okay. So what will be the answer?
What is the
June.
24 June.
24th June 2010.
Okay, so this last line, right?
Yeah,
Yes.
or it's the complete opposite, which is the
How the sort works here?
That is what you have to
April,
tell me.
April 14, 2000. April.
The ascending order.
April 14, 2000.
Sort will
Yes.
basically do in ascending order.
Yes, sort will do it in ascending order, but how is it going to sort these?
So it automatically knows.
Sort according to
No, it will not know that this is a date.
Oh, it
yeah,
will
it will
not
be
know.
just
So
going
these
for
are just
A.
strings. So I'll show you the hint. So the
Okay,
hint is
one second. Sven, just give us 1 second.
Yeah.
So it will
Hint
do.
is string based sort. That means
So first it will like sort alphabetically according to
Yes.
alphabetically, right?
yes. So if you sort alphabetically, out of these, which ones can be at the end?
April should be first. April 4 should be first.
Yes, the 3 Aprils should be the first 3 lines.
Yeah.
Then
April, May.
June is last.
June comes the next.
June
June
comes.
24
May
comes
is
first.
last.
Then June 4, 14, 24 comes.
So April and then June, and then the last
May.
ones will be May.
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 Okay, so the 3 Mays will be at the end. So which one will be at the end?
24.
24.
24, 2010.
But it
Okay,
is not
so-
sorted according to the
Not-
You have to read
numerical,
the hint carefully, right? So this is not numerical sorting. This is string-based sorting. So May, M-A-Y, M-A-Y, M-A-Y is same. Space is same. What is the next character?
Then will come 4 will come.
Yes, right? Because we are comparing 4, 1, and 2. So out of 4, 1, and 2, it will be sort like May 14th, May 24th, then May 4th.
That was not answered today. You can always
Right?
reach
So
out.
hopefully this one is clear. So basically this is sorting alphabetically.
But
And when you're sorting alphabetically,
between May 4 and May 14, shouldn't May 1 come? May 14 come ahead of May 4?
yes, May 14 will come ahead of May 4. So May 14, then May 24, then May 4. So the last line will be May 4. Right, because it's not comparing 14 and 4. It is comparing
It's
1,
about
2,
1 and 4. 1,
Yes.
2, and 4, yeah.
1, 2, and 4. Right, because this is string sort. So in any programming language, if you do a string sorting of these 3, so you will always get, so if you just do string sorting of 4, 14, and 24 also, so let us also see that. So you will always get that way. So if I do, let's say, L equals, so if it has to be a number, that is important. So if it is, it has to be a string. So if it is 4, 14, and 24, so if you do sorted of L, so you will always get it this way, because all string sorting will always check letter by letter. So the first letter is always checked. So 4, 1, and 2 is checked, and 1 comes before, so 1 is there, and then 2 comes, so 2 is there, and then 4 comes. So only when the letters are same, so that is case for the first 4 letters here, then they keep on checking the next letter. So as soon as a letter is found which is not same, then according to that letter, the sorting is done. So here, A, M, and J is first compared. So all the A's are at top, then the J's are in between, and M are in the end. Then for these 3, or the M-A-Y, M-A-Y, M-A-Y is same. Then the next letter which is not same is 4, 1, and 2. So it is sorted as 1, 2, and then 4. So the last line will be May 4. And then this actually does not matter whether it is 2010 or 2001, or even if it's 1990. So because it is sorting from left to right. So this is May 4th is the lowest one here. So the answer of sort and then tail 1 will be May 4. And hopefully this is clear.
Why, how many options?
So many bits.
12
Options are all the options that are given. So you can choose any of them. But yeah, if you are clear with how sort works, then like there is only one clear option.
So it's not multi-choice, right?
No. How can it be multi-choice? If you are having tail -1, then obviously there will be only one option, right? If you're just taking the last line.
Yeah.
So there is only one last line. Yeah. So answer is May 4, 2010.
So which will come first, if capital letterized or small letter? Is there is any difference?
So it depends on the ASCII code. So the capital has ASCII code starting from 65, whereas lowercase has 97. Yeah, so the capital comes first and then the lowercase. You can also try that in any language. So for example, if you do sorted of, you can directly give a string. So A, and B, say B. So you can see that it will be capitals first and then the lowercase. Okay. So let's move on. So the next one is, we have this text. So the actually the contents of the text does not matter. So this is just some lorem text. So if we have this file open in the VI editor, and our cursor is in the first character of the first line. So our cursor is at L, capital L. Then if we run dd capital P, then what will be the output? So anyone? So what does dd do?
Deletes entire line.
Yeah, so it will delete the entire line, and it will be there in the register.
And again paste it.
Yes. So when you're using DD to delete, it will be there in your register or your buffer. So when you're using paste, it will then paste it. So what is the difference
won't do
between
anything.
capital P and lowercase p?
Capital P will be at the end of the paragraph.
No.
That is
So
G.
So capital P will print it on the line above the current line, whereas lowercase p will print it in the line below. So for example, if I open Vim, and here let me write some things. So here if I now delete this, this is 4th line. So that is now in my register. So now if I, so let me also open screen P so you can see what I'm typing. Right, so now if I press P here, so it will print below that line. So see that my cursor is in line 3, and if I press lowercase p, it is printing it below that. So it becomes the line 4. Whereas if my cursor is in line 3 and I do capital P, then it will print above this. So this will then become line 4 and the printed thing will become line 3. Right, so now we have this way. This is 4th line, this is 3rd line. Right, so let me stop this. So now if we are in the first line and we do DD, so then where does our cursor go? Like the cursor was in L, then we did DD, so the first line got deleted. So the cursor basically comes here, right, on D. So this basically becomes the first line and our cursor remains here. So now if we do capital P, then what happens?
It will print exactly on the position where it is, right?
Yeah, so the like entire file remains unchanged.
Yeah.
So yeah, we delete the first line, then again we paste it back as the first line itself. So now the option is what will be the output of this. So basically whichever option matches this text exactly, that will be the output. So
Here they use small p or capital P?
Capital P.
Capital P. Okay.
Right. Okay. All right. So here you can see the first line is Lauren. So here the second option has Lauren. So here this basically is small p, as you can see. So it is pasted below the second line. So this is not correct. And here it is totally different. Right? So the lorem is totally removed, only it is like ipsum lorem. So this is not correct. And here it is telling that it will be printed 2 times, which is also not correct. So if you're deleting and then printing, it remains as it is.
So one doubt.
Yeah.
So while doing the DD and then after P,
Yeah.
so is it like DD is cut that line and then again pasting?
Yeah, you can think of it similar to that. So in Vim, yeah, if you're deleting something, so you can delete it with D or you can delete it with X. So let me again turn on screen key. Yeah, so if I am, 1 second. Yeah, so if I use the X character, so just see the character that is typed here. So if I type X, so you can see the first letter got deleted. Right, so if I type P now, so that character will again be pasted. So now you can see instead of THIS, this becomes HTIS. So if I do the same thing now, so if I again, let's say I go here, if I do X and I remove the O, but instead of lowercase p, if I do uppercase P, then it is printed before the cursor, right? So it goes back how it is. Similarly for DD. So even if you use DD, it will delete the line. So anything that you delete in Vim is always put into the buffer. So you can always paste it back. So there is like no difference between deleting and cutting. Cutting and deleting are the same thing.
So
yeah.
What we call these DD commands and all.
So there's no name for commands as such. So the D command is basically the command to delete something. So you can follow it with any motion. So for example, you might be familiar with the W motion, right? So it moves the cursor to the start of the next word, right? Or be the B motion, which moves the cursor to the back of the start of the previous word. So if I am here, yeah.
Sorry, actually, sir, I want to know, like, I want to learn all the commands now. So I'm asking where I'll find all those.
So you can basically search Vim cheat sheet, and there you will basically get the commands and what they do, right? So here all of the things.
You can learn Emacs also. You know that, right?
Yeah, you can learn Emacs also. So
Emacs or any one is enough.
Yeah, so you can see the option is also given in Emacs. So if you don't know Vim, you can also learn, like you can also use Emacs. So here it's asking the, instead of DDP, if we do control space, then control N, control W, control Y, then what will be the output? Right, so they will always give the same thing for Vim and Emacs. So the answer will always be the same. So whichever editor you are familiar with, you can use that and you can basically answer with that.
Okay, sir. Good.
Okay, yeah. So if you search for Vim, so if you're learning Vim, then you can basically learn through here.
Okay, sir.
Okay. Okay. So hopefully this is clear. So let's move on. All right. So this is the next question. So here the question is, given this script that we have, shell script, which is used to print the common lines between two files. Right? So same as what the grep XFF was doing. So now we have a script that tries to do that. So you have to choose the options that will correct the script. So the script may or may not be incorrect. So here what we are doing is we are doing file name equals $1, file name 2 equals $2. So we are storing the name of both the files given as argument 1 and argument 2. And then we are setting the IFS to be \n. So \n is basically the line terminator in operating systems like Mac and
Next
Linux.
line.
Yeah, so the line, next line. So here then we are doing a for loop. So for line of file 1 in cat file name 1. So we're basically printing all the lines of file 1 and we are iterating over them line by line using this first for loop. And then for all the lines of file 1, we are iterating over all the lines of file 2. So the same way. So we have a nested for loop here. So for lines in file 1, for lines in file 2. Then we are checking if the line of file 1 is same as the line of file 2, then we are printing that line. So line 1, file 1 is printed if the lines are equal. Otherwise, nothing is printed. So then this nested loop will go over all the lines of file 1 and file 2. So all the combinations.
Sir, is it like first name and second name is same? Then it will print. If file 1 and file 2 is storing first name and the file 2 is storing second name, last name, sorry.
Yeah.
So it's like first name and last name is same, then we'll print.
Yeah.
Right, sir?
Yeah, so not just same. So if anyone's first name is same as anyone's last name, right? So it will not check the lines of the same line number. It will check all the lines. So for example, if I so same as what we saw here, right? So in this one, so here we have a line orange, and here we have a line orange, but the line numbers are different. So this is line 4, this is line 5, but this will still be printed, right? Because we are just checking if any line of this is same as any line of this. So that line will be printed here. So then the question is this script correct or is this missing something? So the obvious option, like which is like visible here, so you can already see the answer, is that there should be a dollar before the \n. So why is that the case? So what is this IFS doing? Why do we need this IFS at all?
Input field separator, right? In bash.
Yeah, exactly. So why do we need this?
Yeah. Sir, while we are doing while we are iterating through the files now.
Yeah.
There maybe there were lines separated by in a next line like that. So
yeah.
That's why maybe we need it.
Yeah, so what happens if we don't set it? So if this line is not there at all, so if we're using the default IFS,
it will search in a single line. Try to search.
It will go by character by character.
Okay, so it's between those two answers. So it's not character by character, and it is
Word.
also, yeah, it is word by word, right? So
By
if you don't give any IFS, so the default one will be white space. So it will split the output by words. So it will basically go over each word one by one. So let me see if I can demonstrate that. So let me create.
But when we do IFS, when we do while read line IFS, there we keep it as blank only.
No, for while read line, you're using the read command, right? So the read command by itself will read line by line. So here we are not using the read command at all. We're using the for loop to iterate. So for loop will like split whatever it is iterating over based on the value of IFS. So here IFS by default is white space. So one second, let me just create two files so that we can also see that. So for example, let's say this is hello, how are you? This is a file, and this is hello. So this line is same in both of them. So this may not be in the same line number, but it can be anywhere. So clearly this line and this line is not same, but this hello line is same as the other file. Right, so we expect the output to only be hello. But now if I write that script, sorry?
How is also maybe in the consideration that
so no, asking like the lines which are same. So here only the hello line is same. Right, so here this line is how is everyone, and this line is how are you, and this line is this is another file, and this is a file. So the lines are not same. Right, so
no, so yeah. I'm saying that if we are not doing that, like IFS,
yes,
it will go line by line, and it will consider that this first line and how all a line, this all a line.
Yes. If you're not doing IFS, then yeah, then that is basically what I'm showing. So it will also match words that are common. Right. So let us try to do this. So for L1, so I'll just use shorter code, which will do the same thing. So here, let me directly give the name, which is file1 do, and then for L2 in cat file2 do, and then we will do if L1 equals L2, then we are simply printing that. So echo L1 and then stop both the loops. So here what we have done is we have not set any IFS. So when we do that and when we run this, so bash script.sh, you can see it is actually not running line by line, it is going word by word. Right? So not just hello, but how is also printed, because how is there in both these files, and this is there in both these files. Is there, and it is present 2 times, so it is printed 2 times, and file is also common. So that is
not how, sir. Why not how is printed 2 times?
No, how is only present once, right? So how is only present once here, whereas is present 2 times, once here and then once here.
Okay.
Right. So so when we are basically doing all the combinations of one word of this and one word of this, so we are getting this is with this is and this is.
So which is the pattern?
Sorry.
Which file is considered as pattern?
No, so here we are not using grep, right? So we are simply iterating over both the files. So all the words in both the files. So we are doing a nested loop. So basically we are running a loop inside a loop. So there is no pattern file. So both are files, and we are going over all the combinations of one word in this file with another word in this file. So all the combinations. So here we have 1, 2, 3, 4, 5, 6, 7, 8 words. Right, and here we have.
Is it one word or one line?
So currently it is one word, right? So that is what also we can see, because the IFS by default is white space.
Oh, okay, okay.
Sorry, sir. In the command, it is for L1 in double time it is mentioned.
Oh, sorry. Yeah. So that will still give you the same output. So that was like a typing mistake from my side. It's hopefully right now this is clear. So by default, for will split whatever is the output by white space. So that is not what we want. We want to split by the new line. Right. So that's why what they have done in the code is set IFS to be \n. But this will not work. So basically you can, so you can see if we simply run this, then nothing is being printed. Right, so this is because it is trying to look for a literal \n. So it is seeing, is there any \n in this file? So obviously it is not there literally. So it is not splitting at all. So this entire thing is taken as one iteration, and this entire thing is taken as one iteration, and it is checking if these two are equal. So obviously entire strings are not equal, so nothing is printed. Here, if we like literally put a \n, then it will split by those, and then we will get that the line hello is same. So if we run this, okay, maybe it is still not printing hello, but basically it is printing something else. Right, so it's splitting by the backslash n's. So that is not what we want. We don't want to search for a literal backslash n. We want to search for the new line character, right? So there are two ways to do this. Either you can actually put the new line character, which may or may not be supported, or what you can do is call the ANSI escaping. So usually when we are escaping something in string, we use the backslash. But in bash, if you want such a escaped thing to actually be escaped and not a literal thing, you also have to put a dollar before that. So if you put a dollar before that, then it will treat it as a string, like a escaped string. So now if you run this, why is this still not working?
You save it.
Yeah, I have saved it. 1 second.
So dollar is in, it should be inside the colon or outside the colon?
No. It has to be outside. It also has to be a single quotes, not a
Single quote, sorry.
double quotes. Yeah.
Not colon.
So now you can see that only hello is printed, right? So now it is going line by line. So it's not just checking which words are common, but which line is totally common. So here only this hello line is common, and the other lines are a little bit different from each other. Right. So
if you just give \n without anything, will it work?
No. So this is still just a literal backslash n. So you can see it will not print anything. So for this, yeah.
So instead of backslash n, we can use any other IFS, right?
Yeah. So that you can do. So for example, if you have control over your file, I can say, let's say the colons are the like the line terminators. So if I do that, and if I set the IFS to be colon, then that should also work. Let me try that. So if I set colon as the file,
dollar before the colon.
No, so here you don't need, because we are literally matching a colon, right? So okay, so it is still not working.
Single quotes.
Single quotes.
I don't think that should make a difference. Okay, no. So okay, let's try dollar also.
Dollar,
No. Okay, so yeah, because we also have the backslash n, maybe because of that. So although we cannot see it, but that backslash n is also part of the output, right? So if we have it like in the same line, then maybe it will work. So let me try that. And with this, so now you can see that it is basically only printing hello. So now it is splitting this by the colon. So it is taking this as one, and then this as one, and this as one. Similarly, here also it's taking this as one, this as one, and this as one.
Here dollar is not required.
No, because here the colon is the literal symbol colon, right? So similarly, if instead of actual backslash n, if you had the like literal backslash n, then you could use just backslash n, right? So here, if I make it backslash n, and save both of this. So here now, if I make it backslash n, then you can see that it is working, right? It's printing hello. So, but because we don't have the literal backslash n in the original file, we have the actual backslash n, right? So the new line character. So if I want to escape strings that way in bash, so then we have to also put a dollar here, which is called ANSI escaping. So if you want to learn more about it, you can search for ANSI escaping in bash. So you can get to know more about this. So now if we save this and we run this, so there you can see only hello is printed. If I just change this to how are you, so then this line is also same. So then it's printing hello and how are you. Okay, so hopefully this is clear why we need a dollar here before the backslash n. So that
at the time of backslash n, why it's printing some empty lines?
That I am also not sure actually. So maybe because there were some empty lines, I'm not sure. So maybe for some other reason. But if you want to split by the literal backslash n, then you have to use a dollar here. Basically, if you want to escape anything. So instead of backslash n, if you want any other like backslash t also. So this just \t will just search for the literal \t. So you have to actually use a dollar in that case also.
So what is that \t?
\t is tab character.
Okay. So you were saying about the empty lines, right?
Yeah.
If we're gonna go in the file 1 and press enter after 3, it will create the empty line, right?
Yeah.
So if it is not there, then it won't count.
Yeah.
According to me. And sir, what is how the number changed? As you can see, the line
Which number?
numbers.
Okay, this is relative numbers. If you want, I can turn that off. So, okay, so I have to unset it.
No, sir, I'm just asking.
Yeah, so this is basically like usually you will have like normal numbers. So it will be 1, 2, 3, 4, 5, 6, 7, and wherever your cursor is, the line number will remain same. Whereas this is something called relative number. So it will always show the line number on the line of your cursor, and it will show the basically distance, right? So if I am, let's say here, so knowing the line number of this line may or may not be helpful for me always. But if I know this is 6 lines above me, I can easily type 6K, right? And I can go up. So K is basically the symbol to go up and J is the symbol to go down. So if I know how much I have to go up, I can simply type 6K and go there. Okay, so that is something that is useful if you're using Vim. So some people use relative numbers, some people use the absolute number.
Okay, good.
Okay. So let's move on. So there are multiple options correct in this. Sorry, so there is another option here, which is the code is correct and has no issue. So this is basically contradictory to the first one. So in this code, there is only one issue here, which is the dollar is not there. The option B says that we should not use for loop, and it is incorrect, and we should use while loop instead. So we have to use while with the read. But as you can see, for loop will also give you the correct outputs. Although for loop is a little bit more finicky, as you can see, we have to set the IFS and all. So it is more preferred to use while loop with a read command. But in this case, for loop will also work if you have set the IFS correctly by using the dollar. That's why option B is not correct. And the third, yeah. Rohit, can you mute yourself?
Sorry, sir.
Yeah, go ahead.
No, sir. You continue the third option, then I'll.
Okay, yeah. So the third option states that the if statement is incorrect and it has extra space between the square bracket and dollar, and as well as the like closing curly bracket and closing bracket. So basically, it's stating that we have this space after this square bracket and before this square bracket. It's stating that this is incorrect and we should not have the space. So that is totally opposite of what is true. So basically, if we don't have a space there, then this command will not work and it will give us an error. So only if we have space, only then it will work. So that's why option 3 is also incorrect.
Yeah. So in each line, this is the question where we have to find the error, right?
Yeah.
Sir, what all the possibilities where we can find the error?
Okay. Yeah. So
because it's a very small error. By looking at examples or the options, options, we will come to know that what all the things. But if it is not, and if the question is saying count the errors,
yeah, that will be very difficult. Yeah. So usually that kind of questions are not there. So some things that like you should look out for is, for example, as we saw, the spaces, right? So if we are using single brackets and there is no space, that will give you an error. Similarly, here we have double equal to. So what happens if we give a single equal to?
It will assign.
No, right? So in Bash, we can use both double and single equal to. So yes, in like if you're using the test command, right? So basically this square bracket or the double square bracket. So here you can use double equal to for comparison, and you can also use single equal to for comparison. So for example, here if so right now this script is working, and instead of double, if I make it a single equal to, you can see this is still working, right? So in Bash, both double and single equal to works. And actually, double equal to does not work at all outside bash. So in like the POSIX SH shell, only single equal to works. So the support for double equal to is added in bash because people from other programming languages are more comfortable with this. But both of them will work in bash.
Sir?
Yeah.
Would minus EQ work?
Minus EQ only works with integers. So here we are comparing strings. Right? So it will give you an error. If the file only contains numbers as the entire line, then minus EQ will work. But if there is even a few letters,
no. See, but while streaming it, wouldn't be treating it as a string.
Yeah, so in bash everything is a string, but when you're using minus EQ, it will try to interpret this as a number and this as a number. And if it is a number, then it will go well and fine. But if it is a string, then it will give you an error. So for example, now it will give you an error, right? So you can see a lot of errors. But if I, let's say, change all of this, so if I make it, let's say, lines which only have numbers, so then it will work fine. So let me add a few numbers here. Okay, so, sorry. Right, so here you can see the 62 is repeated, like it is common in both the files. So if I run this, so now you can see it is not giving error, it is printing 62. So if the file only has numbers, then it will work. But if as soon as I add some letters, so whenever it is comparing with that letter, it will it should, okay, it's not giving you an error here. Maybe if we have space, yeah. So now you can see that it is giving you an error. Right, so if it is like just a single like word, then I think it will treat it as 0. So we can add 0 here to check. So yeah, now you can see that it's telling that 0 is present in both of them, which is because this is actual 0 and this is assumed to be a 0 because we are using EQ to compare numbers. So as this is not a number, this was basically treated as 0. So whenever we are comparing any random string, we should not use EQ. We should only use the single or the double equal to terms.
Got it, sir.
All right. Okay. So let's move on. Yeah. So a few other things that you like should keep your eye out for is, for example, if you have a for loop without a do, right? So if you don't have a do, then the for loop cannot start. So the do can either be here in the other line, or it can be in the same line if there is a semicolon between them. But like this. But if you don't have this semicolon, then that is a syntax error. So that is also something you can keep in mind. So for example, you can see we get an error here. Other things, so there can be single bracket, there can be double bracket. But if you're using a regex matching, which is like equal to tilde, then you can only do it in double brackets. So that is not allowed in single brackets. So in double brackets, normal things are also allowed, and regex matching is also allowed. What else? Yeah, so basically that, and also the interpreter. So if you see something like this, right, or if you see something like this, so in that case it is an incorrect interpreter. So it will work if you run it with bash, but if you run it with // then it will not work. So that is also something you can keep in mind.
Thank you.
So let's move on to the next one. So in this question, like the options are incorrect. So the question is select the regex that matches the date before 20220101 and amount is less than 10,000.00. The date is always in the ISO format and the amount is always in decimal format with exactly 2 digits after the decimal point. So note the year is from 2000 to 2023. So we have to match all those years that is between 2000 to 2021, because any date before 2022 1st Jan is same as all the years should be only between 2000 and 2021. So here we basically have to write a regex for that. So let me create a file which has the this data, something like that. So we have company, date, and then the amount. So it can be anything. For example, company A, and then the date is like this. So 20240419. So this has to be between 2023 and 2000. Right, so we have something like this, and these are basically A, B, C, B, A, something like that. So the company does not matter, and the year is basically like 2022, 2021, like that. So here we have to, in this given question, we only have 2020 till 2023, but the option states that it can be from 2000s to 2023. So we can also have things like 2009 or 2015. So because of these options, as we will see, the options, like because of these years, all the options given are actually incorrect. But we can also try to come up with the regex ourselves. So the month and date actually do not matter. Only the year matters, because we're told it has to be before 1st Jan of 2022. So any date that is in the year 2021 or less for the and more than 2000, so that will be in that range. And the amount also has to be less than 10,000. So if here we have 10,000, so let me change it and let's have some amounts less and some amounts more. And so if I have something like this, and these are the dates. All right, so how do we now match all those whose year is less than 2022 and the amount is less than 10,000?
Using grep.
Yeah, so we have to use regex. So we have to use grep. So what will be the regex looking like? So the format of this file system comma. Yeah.
So maybe dot star comma.
Yes, and then
anything, everything.
Sorry, I didn't get digit.
You can give the options, right?
Yeah, you can give options.
Yeah, so it should be 202. So it should not be 2022, right? So
yeah, so it should be from 2000 till 2021, but not 2022.
Yeah, so first
what is the one at the note shine at the bottom that's confusing? The year is from 2000 to 2023, both included.
Yeah, so the file can have will have years from 2000 to 2023, but we only want to print those years, like those dates that are before 2022 1st Jan.
Till 2021.
Yes, till 2021.
The year till 2021 we have to print.
Yes.
We have to search it.
Yeah.
So what if we give?
Right?
Yeah, sorry.
The first character will be first character can be only 2.
Yes, exactly. Yes.
Okay. Okay. Then the next character can be 0, 1, or 2.
We can give the square brackets, right, and give 0.
It should be 0 only, na?
Yeah, the second character should always be 0.
Yeah, it is, 2000.
Yeah.
And then it could be 0 or 1, 2, 3.
Till 0, 1, 2 till 2020. Only
Third character can only be 0, 1, and 2. Then the fourth character can be this one. We can do it this way, right? So 2200.
What's that? 1, 2? 0, 1, 2?
Yeah, sorry. So the third character.
0, 1, 2?
Yeah, so basically it can be 2000 something. So one second. So it can be something like 2000 something, right? 2001, 2002. It can be something like 2010 something, right? So the third character can be 0, it can be 1. It can also be 2 for 2020 and 2021. Right, so the third character can be 20 and then 0.
The next one can be 0 or 1.
Okay, so that is basically the option that is marked as correct. But why this is wrong?
No, it should be 2009 won't be there.
Yeah, so this will
2009.
Yeah, it will not match 2008, 2009, any of those years, right? Because we're telling that the fourth number can only be 0 or 1. So this will
you make that you take a hat inside and put the ones which you don't want.
That will still not work.
So what we can do is, right, we can do expand from 0, 0 till
yes,
1.
yes. So the thing is, you cannot definitely tell that this like the 4th year digit can only be this character, because it can be any character for like 2. So if it's 200, then it can be anything from 0 to 9. Similarly, if it is 201, it can be anything from 0 to 9. Only if it is 202, then it can be either 0 or 1. So you basically have to use the OR to match all the 3 of these. So,
Sir,
yeah.
Sir, I'm not getting that. The right part I got it. The left part where you are right now, I didn't get that 0, 1, 2. And one more thing that comes to my mind. So we are doing the braces. What we do that. Like we create the directories, right? Like that way we can't redo that.
No, so that is in bash, right? That is not a regex syntax. We cannot use that.
Okay, so what is this 0, 1, 2?
So basically the third letter of the year, right? So from 2000 to 2021. So what is the third letter possibilities? So this is not a correct solution, but yeah, this we were following. So it can either be 0 or 1 or 2, right? So from 2000s to 2021. It can be 0 for all the 2000, 2001, 2002 till 2009. Then from 2010 till 2019, it can be 1. And for 2020 and 2021, it can be 2. Right? So that's why these are the 3 options. But we cannot do it this way. So we basically have to create 3 options for it. So what we can basically do is we can then create a group here. And then we can say it will either be 0 and then 0 to 9. Or it will be 1 and then 0 to 9. Or it will be 2 and then 0 to 1. Right, so
the right part we are writing in the left part.
Yes, exactly. So this you can actually compress even further. So instead of writing this 0 and 1 thing separately, you can also make it as this. So you can say this. So you can say it has to be 2, 0, and then either 0 or 1 followed by any character from 0 to 9, or 2 followed by 0 or 1. Okay. So hopefully this is clear. So the first part is any year from 2000s to 2019. And this is only for 2020 and 2021.
Little complex, sir.
Yeah, but then like this is regex, right? So if you're familiar with regex, you should be able to like slowly build it one by one. So ideally, like in Enter, we will not have to build it. So we'll have the options, so you can go through them. But for this question, none of the options are correct. So going through them will not do us any help. So I'm simply building it on our own. So this will also help you checking options as well if you're able to build it. Right, so now
the option is given, right? Third.
No, so all the options are incorrect. So it is like you can see it is what we were discussing earlier. So 20 and then 012 and then 01.
Okay.
But this will not match any like 2019, 2018, nothing.
Good.
Right, so this will match all the years, and then so this is the hardest part. So matching the year. After that, we can match any month, right? So how do we do the rest part?
Same thing. The month can be of 0 to 12.
So it should be an hyphen, and then it will be 0, 0 to first character can be 0 and 1.
Okay.
0 to 12. 12.
Okay, so the first character is 0 or 1, and the second character?
0 to 9.
0 to 9.
No, 1 to 9. No, it can, yeah, it can be 0. 10 is 0. 0
so like this, if we are given correctly formatted dates, this will work. But this will also match incorrectly formatted dates, right? For example, this will match 00. This will match 19, 19, 18, 18. Right? So like
just one.
That is not our responsibility, right? If the input data is garbage, how can we? Are we supposed to validate data as well?
No, so the main use case of regex is for validations, right? So when you're writing a regex, your regex should validate only the correct option and not the incorrect options, right? So here, if you are saying 01 followed by any digit, then this also matches 18, 19, etc.
So
right?
one thing.
Then we can do the same pattern which we did in the first one. So 0 will be
0 to 9.
0 will not have 0 to 9. 0 will have 1 to 9.
1 to 9.
Yeah.
Or
it will be 1.
0 to 2. 0 to 2.
0 to 2, yeah.
Yes. And similarly for the date. So the date is simpler. So you can just say, so you can say 0, 1, 2, 3, and then it has been 0 to 9. So here also, like, we are matching 0, 0. If you want, you can also separate that. So it will be done.
We are doing 39 as well, so there is no 39.
Okay. Yeah. So we have to basically do it separately, right? So if it is 0, then it can only be 1 to 9. And if it is 1 or 2, so 1 or 2, then it can be 0 to 9.
But in 3, it should be 0.
Yeah, or it can be 1. So yeah. So here, like, you cannot actually check whether the date is correct for the month, because that is beyond the scope of regex altogether. So
you see, now if it's 31st February, it also comes correctly.
Yes. So here, like, this part of matching you cannot do with regex at all. So there you need logic. But this part you can do it with regex. So now, yeah.
Sir, while writing the 0, like in the 3, right, 30 date, 0, 1 don't have the like the sign
dash minus. Yeah. So if you give 0-1, that means 0 or 1. If you just list the numbers in the list, then also it means only those. So
like
for
we
cases
can
when
write
it is
0, 9 also.
If you write 0, 9, that means either 0 or 9.
Okay. I got it. It's 0 to 9.
Yeah. If you want 0 to 9, then you have to give the dash.
Got it.
Okay. Yeah. And so now, like, the date is done. So then we will just have the comma. And the second condition is the number has to be, okay, I forgot to give the dot actually. There should be a dot 0, 0. Right. So what will be the regex? Sorry?
Considering float values?
Yeah, so here it is told that it will always be 0, 0. So the amount is in decimal format with 2. Okay, so it is not told always 0, 0. It's told it will always have 2 decimal values. Right? So it can be any decimal values. So what you have to do is you have to match numbers that are lesser than 10,000. So how can we do that?
Sir, we can do by using that LE.
Sorry?
No, not LE, L.
No, so that is dash, right? So you cannot use that in regex. So you have to only give the regex that will match this. So here, like, if the question was lesser than 1990, that would have been hard. But here the question is lesser than 10,000. So what property of a number will always satisfy if it's lesser than 10,000?
So it's 4 digits.
Four digits. It's always 4 digits, right? Yeah, 4 or less.
Curly braces 4. That is one thing.
Yeah, so we'll have any number 0 to 9 present at max 4 times. And then we should always have the decimal, right? So we should have the dot.
I think at max 5 times.
Why?
Oh, 10,000 is 5 digits, right?
Yeah. 10,000 is 5 digits.
But what if there is a 9? So 9 5 times is greater than?
Yeah, 9 5 times is greater than. So we want any number less than 10,000. So all numbers less than 10,000 are only 4 digits or less. So no 5-digit number is less than 10,000. 10,000 is the smallest 5-digit number.
Sir,
yeah.
Can you very briefly say what the difference between this 4 comma and then nothing comma 4 and then let's say 2 numbers?
Yeah, so nothing comma 4 means the 0 is implied. So it is
0 to 4 times.
Yeah, it's 0 times or 1 times or 3 times or 4 times.
And 4 comma nothing means 4 or more than 4.
Yeah, so 4 to infinity.
4 to infinity. And if there are 2 numbers, so let's say 5 comma 10, so 5 to 10 times.
Yes, both are inclusive.
Achha, okay.
Yeah. Right, so after the decimal, we simply have like any number present 2 times. Right, so this is basically, so we also have the end of line here and the start of line here. So this is basically the correct regex that should be. So unfortunately, like all the options are wrong here altogether. So we cannot go through the options. So here you can see like the dot star is correct. So this year matching part and the month matching and the date matching is incorrect. So especially the year. So the month and date, we can say we don't want to validate, but the year is not matching correctly at all. Right? So that's why no of the options here is correct. And then, so then we basically match any number present. So here it is matching exactly 4 times, right? Whereas the number can also be present less than 4 times. So that's why this is also another incorrect. It should be comma 4. So any number present less than or equal to 4 times. And then we have a dot and then any number present 2 times. Right. So this is basically how we will be matching that. Just let me know if this is clear.
Sir, it's clear, but it's too complex to understand.
Yeah. Right. So usually this will not be there because
only the year is a little bit thing which we have. It's tricky to think, or even we don't know in the exam that the options are wrong also.
Yeah, so if the options are wrong, you will get marks for any of the options. So that will not be considered basically. So like if the options are wrong, then it's kind of like a good thing. So you can basically not
But
worry
sir,
about that.
we'll waste our time, na?
Yeah, that is so. Hopefully, like no wrong options are there in the paper. Right, so just let me know if like this part was clear, the year part. Okay.
Clear, sir. Okay. Everything clear.
Okay. All right, so let's move on to the next one. So here we have which commands can be used to select the package name and its version as shown in the desired output from the following log file. So here we have a log file. Your solution should satisfy the sample output given the sample input. So this is the log file that we have. So the log file shows the date and then the status installed nginx common all. So this is the version of the package and this is the name of the package. And so similarly, we have some other lines also. So this is configure lib nginx mod http, all this, and then this is again lib nginx, and this is lib nginx. So same thing. So here the desired output is simply this part. So nginx common, lib nginx, lib nginx, lib nginx. Right, so we actually don't care whether it is like status installed or configure or status unpacked. So for all the lines, we just want this part. So the nginx, so anything till that colon, including the word after the colon. Right, so what is the, like if this file is always structured this way, what is the simplest way to do that?
Sir, by doing that, sorry. Sir, that is the space separated, na? So
yeah, so this is always separated by space. Yeah.
Third, what we say? No, 1, 2, 3. Yeah, third. 0, 1, 2, 3, na? Third, what we will say? Third word.
Yeah, yeah. So it's not third because we start with 1. So it's the 4th word. Yeah. Okay. So if you split by space and you take the 4th word, then you can get this one. So let's see the hint also that is given. So here, okay, so here they've given the hint of grep. So most probably all the options are also grep and not cut. So hint of what the -e, so that is obviously extended regex, and what the -o does is given. And also how you can like match word boundary is given. So you can use -b to match any word boundary, or you can use the /b to match any word boundary, or you can use /less angle bracket and /right angle bracket to match the empty string at the beginning and the end of the word. So like basically /b matches both of them, whereas these matches only the beginning or the end of word boundary. And so the examples are given also of repetition, and then we have options with grep. And so if you only want to match this with grep, how can you match this? So the hint is that they will always have the colon in between them.
Yeah, by colon also we can separate the fields.
Yeah, but the options will like not using cut; they're only using grep. So what regex pattern can we use to basically get this? So one can let me.
So something followed by a colon and then something.
Yes, and so if you just give some like anything which is dot star, it will also match the space and everything else.
Yeah, so it's alnum, right? So we have.
Yeah, yeah. So here we also have a dash. So alnum will not consist dash. So like the safest thing I can think of is like giving the cap and space, so not space. So anything that is not a space. So let me actually write this in a file so that it's easier to see.
Sorry, sir. What you said, I didn't get. What was
Yeah,
that?
so let me write that so it will be clear. So let's say we have this log file, right? So 2023, I'll just write one line. Status installed Nginx common and all, and 1.18 point something, 0 dash, yeah. Right, so if we have a line like this, so if we just match A to Z, or let's say also capital A to Z in this file, so there you can see this Nginx is matched, common is matched, but this hyphen is not matched, right? So like if there is maybe hyphen or maybe underscore, so those will not be matched. So the safest thing we can do is match any character except space, right? Because we know that package names cannot have spaces. So the package name will always start with any character that is not a space, and it will go on till the colon, and then again we have this one word which is any character not a space, and then we have the space. Right? So here if we search for not A to Z but cap and then space, right? So this means any character except space. So now it will it looks as if everything is selected, but the spaces are not matched by this pattern. So now if I say this thing, which is any character except a space present anytime
With colon also.
Yeah, so basically this is matching colon also, but then we have to like explicitly match the colon so that the other things are not matched, right? So only this is matched. So for that, what we can do is any character not a space present any times followed by a colon, and then again any character that is not a space present as many times as possible. So then this first part can only match up till here, right? Because then the next one is a space, so it cannot match it. And similarly, this second part can only match till here because the next one is a space. Right? So now you can see it will only match this part. So now how do I get only this and not the entire line?
-4.
-4. Right? So if I use -4, then
matching.
yeah, it will only print what is matched. So this was my solution. Let's see what is the given solution. Right, so here they are using alnum and the dash. Right, so that is also what you can do. So if you know that the name of the package can only consist of alnum and the dash symbol, right? So nothing else. So then you can also be more specific and say match any character that is alphabet, numerical, or the dash. Right, so usually when we write alnum, we give double square bracket colon alnum double square bracket. But if we want to match multiple things, so basically what we do is the first square bracket or the outer pair of square bracket is basically the list. So just like we give square bracket A to Z. So this outer square bracket simply means that this is a list of characters that can be matched. Or I can also do like I can write some characters and only those will be matched. And then the inner one is used to signify the character class. So here square bracket colon alnum square bracket signifies all the characters in the alphabet and the numericals. And along with that, we also want to match the hyphen symbol. So we are matching alnum and the hyphen. So here you can see the correct solution. We are matching any character that is either lowercase, uppercase, or numerical, or the hyphen symbol present as many times as possible, followed by a colon. So we have to match the colon so that only that part of the string is there. So otherwise, these are also alnums. Right? So we only want alnum followed by colon and then followed by another alnum. So that is how we match only that part, and then we use -O to only print the matching part.
So how the last option is different from others?
So let's see others. So in the second one we are using.
So first we'll compare the third and fourth.
Yeah. Okay. So let's see this one. So the alnum is same. So instead of plus we have star here, and again here instead of plus we have star. Everything else is same. Right?
What that plus is, sir?
So plus means 1 or more, whereas star means 0 or more. So this can match 0 characters also. So if the name of the so if there is also any other colon, right? So not just this, but let's say somewhere else in the line there is a colon with nothing to the left or to the right of it. So here this star will match even the empty place, right? So lnum star colon lnum star will also match just a single colon if that is present. So for example, here here we are using star, right? So here if let's say we have a colon present here with nothing to the left or to the right of it, that also will be matched, because I am telling that it is present 0 or more times. So that means this is optional. This may or may not be present. Whereas if we use the plus to state it has to be present at least once, then that will not be matched. Only the colon that has something to the left and right of it will be matched. Right? So that is the difference between star and colon. Sorry, star and plus. And what is the difference between the first, like the second and fourth one?
So
we have the plus.
One more thing.
Yeah.
In the second option, the plus is there. There is not a circle bracket, and the symbol is not a circle bracket. What's that? Grouping.
Yeah, we have the grouping here, right? So, but what is the use of that? We don't actually need to group anything, right? So in here, yeah. So the second option should also be correct. The fourth option should also be correct. This is most marked.
Can you try running the second option and check, if it is not much of a thing?
Yeah. So
till now, I didn't group anything. What we did, it's working.
Yeah, exactly. So if we don't group also, it should work. So for example, this plus colon, then same thing. So here num colon.
After that plus.
Yeah, and there's a plus at the end. And if we run this on log, you can see this is still matching. So whether you group this or not, that will not change the matching. So grouping is only useful when you are back referencing that group. So here, anyway, we are not referencing it. So having or not having the group won't change the output. So here, most probably this is marked incorrectly. So both the option B and option D should be correct. Whereas C and A, they have star. So it may also match the empty strings.
So one thing.
Yeah.
Where I'm still confused. They're using the 2 square brackets inside the group also. What that is? Like,
so the first one is for the listing. So here we can basically list anything, right? So for example, instead of doing square bracket lnum, what I can do is I can say A to Z, right? So A to Z is also a list. So I'm telling from all the characters A to Z, you can match that. So here you can see instead of matching nginx dash common, it is only matching common, because hyphen is not part of this list. Right? So similarly, I can also list out the characters. For example, I can say it is N, M, O, C, only these. So then also you can see common is matching, because common has the characters which is N, M, O, C. Similarly, if I remove, let's say, C from it, then only like the word after C will be matched. So this is just the bracket for the list. And in here, if I want to use a character class like lnum, for example, so this inner square bracket is for the character class. So if I just do lnum, then again it is not matching the hyphen, right? Because hyphen is not part of alphabets or numbers. So if I want to also list the hyphen, then we can basically put it here. So the inner square bracket is for the character class. So we just do square bracket colon lnum colon square bracket. Then the outer square bracket is all the list of characters that is accepted. So this character class is accepted, and also this minus symbol is accepted. So then we get this entire matching.
So one thing. So in this like you're saying character and the list. Earlier we were like matching the list NMO in that. So is it like a word by word it is matching if it is there, right?
No, it is matching character by character. So each character it will see. Yeah, it will see if any of these is matching, then it will match that.
And in the LM.
So here also same thing, but instead of listing out all the alphabets and numbers, right, because there are a lot of them, we're using this shortcut. So this square bracket colon lnum colon square bracket will expand to all the alphabets and all the numbers.
Okay.
So we can also do that, but it'll be a lot of characters.
What is that minus OE, sir?
So minus O, so that we only print what is matched and not the entire line. And E, because we are using extended regex, right? So if I don't want to use E, then I have to escape the plus and also the brackets.
All clear, sir.
So let's move on to the next one. So in here we are told that Anish wanted to extract phone numbers from the following data. He knows that grep OE can print the pattern selectively using ERE. Please help him choose the correct regex from the options to achieve that. So basically there are two types of phone numbers, right? So either the phone number follows this format, 1 character dash 3 characters dash 3 dash 4, or it is 3 character dash 4 characters. Right? So we have to write a regex that matches both of these formats. So here you can see we have this input data where we have name, phone number, email, and region. Right? So you can see that dash is there in the email also for some people. So we don't want to just match dash. So it should also follow in this format.
Yeah, so digit plus dash, digit plus something. No,
number instead of NM.
Yeah, so you can use that, but we also have to.
So why not use cut minus D and field with the field separator as
We
comma?
specify particularly that we want to use
So
grep.
here, like all the options are of ERE only. So obviously you can use cut by comma and take the second field. That will be easier. But because the question asks for the regex that matches, so we have to only use the regex. So here there are like generalized solutions and then specific solutions. If you only want to match these two patterns, so let me just add this as the data.
According to this thing, right? We have to touch our mouse by going around our head.
Yes, exactly. So this would have been easier with just cut. So let's say let's just add a few.
In the previous question, we use alphanumeric, right?
Yeah.
Here we can use numerical only.
Yes, yes,
then
we can
it
do
won't count that the words.
Yes.
And the dash.
Yeah. So let me just add a few data. Yeah. So this way and then something. So this one was Madan Raja.
So you don't need to write that first line, right?
No, so the yeah, I don't need to. I'm just copying some lines. So I'll just add one more line, which is the different format. Okay, so this is this one, 474, and then 7526, something like that. Right, so basically we should be matching both these patterns. So you can either use like a generalized statement, like as you said, we can say any number, right? So if I just match any numbers, sorry, I have to use double square brackets. So sorry, I think it's not num, it's digit. Right, so if I use digit, then we will match all these digits. But I want not just the digits, but also the dash. So one thing we can do is we can match the structure. So what we can do is a digit present 3 times, and then followed by a dash, and then again. So here, let me use 0 to 9 so that both are correct. Right, so if I use this, so now we will get this and this.
OE.
Yeah, but yeah, and now if I use O, but we will only get what is matched. So we basically want to have both the regexes, one for this kind of numbers, which has 3 digits and 4 digits, and one for this, which has
we'll group it and use OR.
Yeah. So what you can do, because the last part is same, right? So 3, 4, you can just put it at the front. So what you can do is instead of like doing the entire OR, you can also put just the left part, which is so 1 digit, so 0 to 9 present once, followed by a dash, and then 0 to 9 present 3 times. Right? And this part you can give as a question mark. So what does question mark mean?
Either it will take or not.
Yeah, so it is present either 0 or 1 times. It cannot be present multiple times. It can be present 0 times or it can be present 1 time. So we don't need the grouping here.
It won't be a problem if it is not there, right?
Yeah, so if it is not there, then it will not match. But if it is there, then it will match. So, okay, so here this is not greedy. So it is, even if like we have it, it is not printing it. So
because after before what we can use the dash also, na?
Yeah, you
okay,
yeah.
You missed the dash. Yeah, thanks. So either like we will only have this part 3 digits and dash 4 digits, or we will also have 1 digit dash 3 digit dash before that. Yeah, right. Yeah. So thank you for this. So this is basically one of the ways to match it, or we can just put the entire thing and then give a or. So I can just say this thing, this entire thing, or this basically same thing, but only the last part. So 0 to 9 present 3 times, and then dash, and then 0 to 9 present 4 times. Actually, we don't need the grouping because the entire thing is part of our regex. So yeah, this is also one way of doing this, and this is also one way. So because we are the second part is just a sub part of the first part. So these are the specific ways just to match this pattern. But if I just want to match any dashes, so if I just use dash, then this will not match because we also have dash in the mail. So we have to only match dashes that are surrounded by numbers.
Sir, I didn't get. Sir, could you please?
Yeah. So if I let's say
both the lines, those are considered as answer.
Yeah, this one and this one, right?
Yeah.
Yeah. So this one, hopefully it's clear, right? So what we're doing is I'm matching any character, any digit, dash, any digit 3 times, dash, any digit again 3 times, dash, any digit 4 times. So this is matching this kind of numbers. Or we are matching any digit 3 times, dash, any digit 4 times. So that is matching this kind of numbers. Right, so we have 2 regexes, one for matching this kind of numbers and one for matching this kind of numbers. Right, so hopefully this one is clear. And
sir,
yeah.
The thing is, we are using pipe here. Above also we can use pipe in instead of question mark.
No. So here we are using pipe because this entire thing is one pattern and this entire thing is one pattern. Okay, right? So, but the above one, what we are doing is I'm telling either it can be this, right? So 3 digits followed by 4 digits, which is this one, or it can be 1 digit followed by 3 digit followed by 3 digit followed by 4 digits. So this part should always be there. So the 3 digit followed by 4 digit, this is always there. And before that, we may or may not have 1 digit followed by dash followed by 3 digit followed by dash. So this part may or may not be present, but this part should always be present.
Sir, yeah. You write the digit, right?
Yeah.
Digit, colon.
Yeah.
Sir, can we remove it and write the number here?
Yeah, that is same as that. So that's why I've used both to show that both are the same.
Where else we can write that digit instead of 09 we can write everywhere digit.
Yes.
Like
yes.
the pattern.
Yeah.
Got it. Clear, sir.
Right. So, yeah. So let's see the options also.
Okay. So everything is 09 only.
Okay. The options is all of these. Yeah. So basically what we have is 0 to 9 present once, then 0 to 9 present 3 times, then 0 to 9 present 3 times, 0 to 9 present 4 times, or 0 to 9 present 3 times and 0 to 9 present 4 times. Right. So as we saw this second one. So that is
3 3 4 and 3 4, right?
Yeah. 1 3 3 4 and 3 4. So okay. Then the second option is 0 to 9. So same thing only. But instead of like we don't have the backslashes. So dash is not a special character. So we don't need to use backslash. So as you can see in the solution, we have not used backslash. So if you use a backslash here, if you escape the dash, so in some cases it will work in some greps, but in some greps it will give you an error. Right, so here you can see we are still getting the answer, but we are also getting a warning. Right, so the output will still come. Yeah.
It's ERE, that's why we don't need. If it
No,
is
in
BRE,
either ERE or BRE, the hyphen does not have any meaning, right?
then why it is correct?
So because even if we give a backslash, then also the output is correct. So we're getting a few warnings because that is not required, but the output will still be coming.
Sir, what is the list of special characters?
So the list of special characters that are like part of BRE, so you can get from the BRE syntax, right? So we have star, which is meaning like any number of times, whatever was the previous one. Dot, which means any character. Cap, which means the start of line. Dollar, which means the end of line. And then the square brackets, which are used for this listing. And anything else, you have to escape. So plus, question mark, these things you have to escape in BRE, but not in ERE. So that you can see in the previous page here. So question mark plus parentheses, braces, and pipe. These 1, 2, 3, 4, 5, 6, 7 characters, they need to be escaped in one, but not in other, depending on what you want to do. But
the cap is used for start of the character and for negation also.
Yeah, so if it's inside the list, then it's negation. If it's just in the regex, then it means start of the line. Right, so hopefully this is clear. Yeah. So the third option is the same as the second option, but we also have the \b, which is the word boundary. So we are saying that the number should be a word of its own, right? And which is true because we have a comma to the left and to the right of it. So comma will basically act as a word terminator. So comma can be also considered as the word boundary. So here, if we use \b also, then also the answer will be same. You can see, let me remove the backslash before the hyphens. So if we add the \b here and \b here, then it will still give the same output, right? Because we have commas to the left and right of it. So this is also a correct solution.
Taking as a string.
Sorry?
Taking the it is taking as a whole word separated by commas.
Yes. So basically, we cannot have any other number to the left of it. So for example, here if I have 2, 1, so if I just print this, so you can see from this 2, 1, from the 1 till the end of it is printed. Right? So that is not correct. So if I assume this is an incorrect phone number, I should not print it at all. Whereas what I'm doing is I'm just printing the substring of it. Right? But if we use the \b and ask it to be a word boundary, then it will not print that. So it will only now take from here. Right? So because this 2 is not considered a word boundary, whereas a hyphen is considered a word boundary.
Because we limit only we only consider we are not typing it for 2 times, taking the number. For the first number, we said that it should be only 1 time. That's why maybe the problem.
Which one?
The digit, it is 2. 2, 1 is having 2, and we are considering only 1.
Only 1.
That's right.
Yeah, exactly. Yeah. So even if like there is a letter here, for example, so we don't want that number to be printed at all, right? So like we don't want to just take some part of it. So here you can see from A1, we are taking just 1. Right? So that's why the word boundary is also correct. So if the expression is well formed, then this will also give you the correct option, and word boundary will also give you the correct option, because commas will act as word boundaries.
But sir, while writing the A, and if we're gonna give the word boundary, is it gonna consider?
No, so then it will try to find the closest word boundary. So here, because we are also matching this thing, right? So 3 digits and then 4 digits word boundary. So then it will try to match this part. So only this part.
I'm saying write in the file, write before A1, write A.
Yeah, so that's what I'm saying. So if you do this and then you run this, so here we don't have a word boundary and then this pattern. Right, so what it is trying to now find is just this part. So actually what we should do is we should also have a word boundary here. So we should use the or, so not the question mark. So if we see the It's not there. 1 second. Basically, the one which had or, right? So this entire thing, or just the last part. So 0 to 9, and then present 3 times, and then dash, and then 0 to 9, present 4 times. So if you have this and you put the word boundaries in the correct places, so, and I don't need the round brackets. So then what it will do is, because this pattern is now not matching, right? So the bigger pattern, because we don't have a word boundary followed by that pattern and a word boundary. So then it is trying to match the smaller pattern, which is just 3 digits followed by 4 digits. So here this comma is matching the word boundary, and here this hyphen is matching the word boundary. That's why it's printing only this part. 987 1 2 3 4.
Got it, sir.
Okay. If the given data is correctly formatted, then both having or not having word boundary will give you the correct answer. Okay, so we have the first 3 options and the 4th option. So what is the difference between that? So here we have a dot star instead of the hyphen. Right? So after the first digit, we have a dot star, and then we have the 3 digits followed by 4 digits, and then the word boundary, or it is 3 digits followed by 4 digits and a word boundary. So given in this input, even this 4th option, so although this is not always correct, but this 4th regex will also match all the correct options in the given input. So here what we're doing is we're matching any so word boundary and then any 1 digit followed by any character any number of times, and then 3 digits dash 4 digits. Right? So here it will match the bigger patterns, and the or part will match the smaller pattern. So 3 digits and then 4 digits. And so here the third option will not work always, but it will work for all the inputs that is given in the sample input.
Sir?
Yeah.
Like it will not gonna work. We took the example A1 and something.
Yeah. So if the A is after the 1, right? So if it is 1A, in that case, it will still consider that. So it will print that. So,
but according to our answer, it should not correct, right, sir?
Yeah. So given the sample input here, all of these are like well formed, right? So there is no wrong numbers. So that's why this will also work in this sample input. Right? So that's why we have all of these in this. Right? So let's move on. So the next question is, what will be the output of the last command in the following sequence of command? So first we've shown how the SEQ works. So if we have SEQ 10, it will print 10 lines from the numbers 1 to 10. So then we are running SEQ 10 sed 1D semicolon 2D. So what does 1D 2D mean?
Deleting?
Yeah, so we are deleting or dropping that line, right? So 1 and 2 are the line numbers. So if we remove the first and the second line, so it will basically print from the third till the end. Right, so the answer will be 3 to 10. Yeah. So this is the correct option. So we can have multiple sed commands separated by semicolons.
Sir, is there any other than delete?
Yeah, so we can have P to print a line, D for deleting a line, then S is for substitution.
Okay.
Right. So yeah.
Good, sir.
So let's see the next question. So here we have the sample input data is provided as follows. The actual file is very long. Vinisha wanted to see if she could filter data using 2 conditions using bash. She wanted to look at all the sales and HR department entries with salaries higher than 50,000. So it has to be sales or HR. So the third column, which is department, it cannot be anything. It has to be either sales or HR. And the salary, which is the last column, it has to be higher than 50,000. So which of the options contain the code that will achieve the filtering process? So here we are basically using awk. So all the options are awk. So in awk, what we can do is here the separator is tab. So we don't have to set the FS. By default, any white space will be considered. So here, what we want is the...
Excuse me, sir.
Yeah.
Sorry to disturb. Sir, could you please mute Ganesh?
It is... Okay, yeah.
Thank you.
So yeah, so here what we want to do is the third column, which is the department, it should either be HR or sales. So it can be HR or sales. So we will do is if $3 equals HR, or if $3 equals sales, and the second condition is the salaries are higher than 50,000. So this should always be true. So if this is true and either it is HR or sale, then we will print the lines. So we basically check if HR is $3 is HR or $3 sales, and $4 is greater than 50,000. So this condition should always be true, and either of these two conditions should be true. So that's why we have to group them in a like round brackets. So in the second option, we have the same thing, but without the round brackets. So here what will happen is we will get this $3 equals HR, or $3 equals sales, and $4 equals greater than 50,000. So either these two is true, or just this is true, whereas that is not what we want. So this will print all the entries of HR. So whether the salary is greater than 50 or not. So that's why we don't want this. We have to group the condition. The third option, so we have basically the symbols are incorrect. So we have $3 equals HR and $3 equals sales.
Hello, sir. This and
yeah.
and or this to be taken from the right hand side.
No, so it is always done left to right. So here the first one we have or all, right? So this one will be evaluated, or this entire thing will be evaluated. So that is not what we want. We want this thing to be evaluated, or and this thing to be evaluated. That's why we have to group it with a round brackets. Right, and in the third option, we just have the symbols wrong. So $3 obviously cannot be both HR and sales. So this will never be true. And we are just checking the salary. So that's why this is incorrect. And in the fourth one, again, so the symbols are incorrect. So the first two have the correct symbols, but in the second one, the grouping is not done correctly. So the first one is the correct way to logically group this.
Got it.
Right, so let's move on to the next one. So here we have the following awk command is executed on the terminal. Which of the following is true about the output of the command? So here we have awk, then / / count plus equals 1 and print count. So when will this regex be matched? So what does the dot mean?
Anything?
Any character, right? So whenever there is any character in the line, so then what we're doing is we're incrementing the count. So count will start from 0 by default. So we're incrementing the count, and at the end we are printing the count. So what will this print then? What will the value of count signify?
The number of empty lines. It's
yes,
number of non-empty lines.
Yes. So for every line, if there is at least any character, it will increment the count by 1. So it will basically contain the count of all those lines that are non-empty. Whereas if there is an empty line, then this regex will not match. So for empty lines, the count will not be incremented. So count contains count of all the non-empty lines.
So basically, it is not printing the characters, not counting the characters, just the lines.
Yes. So for each line, this is just checked once.
Got it.
Okay. Let's move on to the next one. So here we have select the command that kills the process not owned by the user root and consumes the maximum CPU time. Assume you have the permission to kill any process. So in the 10th column of the output of PSAUX command, time contains the total CPU time used by the process. The PSAUX command can list all the processes owned by all the users. Right, so if you do PSAUX, you will get output like this, where the first line is the header, and then you have the user, and then the PID, the CPU percentage, memory percentage, and all. And this time, which is the 10th column, basically is the total CPU time used by the process. So we want to kill the process that consumes the most CPU time. Right, so how do we which process will be the one that consumes the most CPU time? So the line that has the maximum value for the time column. Right, so we first have to remove all those lines that are root. So for example, if So if we do PSAUX, so here you can see the users processes will be listed, but also root's processes will be listed. Right. So I obviously don't want to kill any process owned by root. It's told only processes that are not owned by root. So out of this PSAUX, how do I remove all the lines that start with root?
Grep minus v root.
Yes.
Grep
So,
minus v root.
yes, we can do grep minus v root. And just to be safe, so that the root is not present anywhere else, I can also say starts with root. Right. So only if the line starts with a root, then I will not print that. Any other line, I will print that line. Right. So now you can see we are only getting those lines that are like those processes that are owned by other users and not the root user. So now, how do we get the 10th column of this?
Field.
Sorry.
You can separate. We can
minus D. You can cut minus D
So,
space minus
reverse the string and then first the string.
okay, so that will also not work.
So sorry, before that we have to truncate.
Yeah, you do a TR. You do a TR first.
Yes, so we have to first squeeze these spaces, because you can see there are multiple spaces, sometimes more spaces, sometimes less spaces. So if you squeeze all the spaces, then every column will be separated by just a single space. So then you can cut by space. You can say the delimiter is space, and you can take just the 10th field. So now we have the just the CPU time.
all time.
Yeah.
And
So how?
1.53.
Short minus RN.
Yes. So how do we get the biggest one? We can use the sort, right? So if you do Rn, so it will be in the reverse order. So the highest one will be at the top. So if I remove the R, you can see that the greatest one will be at the bottom. So if you do sort minus Rn, you have to do head minus 1. Or if you do sort minus n, you have to do tail minus 1 to get the one that is the maximum. Right, so this is obviously changing. So it was 42.03 that time. Now it is 42.08. Right, so this way you can get the maximum one. But now how do you get the one which is like, what is the PID of this? So you cannot get the PID back from it. Right, because we have already cut the columns. So you no longer can access that data. So instead of cut, yeah.
Sorry. Sir, we can do like that, na? Like first we'll grab that line, then inside that we'll cut the time and the PID.
No, you can cut the field. I think process ID is the first one, right? So you can cut F1, F10.
The process ID, I think, is the second one. Yeah.
Second one, yeah. So F2, F10. So let's do that. Let's keep both the field.
Yes.
And then, okay, now we want to sort on the second field.
Yeah.
Right. So we have to do short minus N2.
RN.
RN is sure, but F2.
No, it's not F, it's K.
K, yeah.
K. Yeah. So if you do, yeah. So K is basically which field you want to sort from. So we are sorting only from the second field, not the PID. Yeah. Right, so
say field by K in sort.
yeah. So which field you want to sort by? So if I just do this, you can see we have the PID and the time. So now if I ask it to sort like Rn and then take the second field. So okay, why is this not working? So let us give the T also. Maybe that is the reason. Okay. No. Okay, so let's make our life a little bit easier. So instead of having the time as the second field, what we can do is we can have the time as the first field. Okay, that actually does not work. Okay, yeah, so let's just have it this way. So the second field and the 10th field. And
some disturbance
sorry?
Reverse also.
Some disturbance is there.
Yeah. If you're not speaking, can you move? Yeah. Okay, so we have, if we use sort minus K2, so why is this not working? So what is wrong in this sort? Is there a space before? No, there's no space, right? So what we can do is we can just like swap them. So what we can do is, if you're using awk, I can simply ask it to print $2, then $1. So then our life will be a bit easier, right? So now you can see the time is the first column and the PID is the second column. So now we can directly use sort minus NR to basically sort by the first column. So if I don't use the R, we get the biggest one at the end, and if I use the R, we get the biggest one at the top. So either way we can sort, and then appropriately we can take either head or tail. So if I take tail 1, so I now have that process which is not owned by root, that is taking the maximum time and its PID. Right. So now it's very easy. So how do I extract the PID?
Cut minus D F2.
Yes, cut minus D space F2. So now this is the PID. So now how do I kill this?
This entire store it on a variable and then kill that.
Yes, both are correct. So you don't need to store it in a variable. What you can do is you can just put kill here. Yeah. So kill this, or you can use XRs as you mentioned. So you can either do this. So I'm not going to do this because I don't know what this process is. Most probably something important. Or we can do XRs kill. Right. So either way, this will be killed.
Sir, why we are so much thing we are doing and now we are killing? Like
yeah, so we want to kill it.
So complicated.
Yeah. So
most probably
there is a better option, right? So okay, yeah, here you can see. So this is not the, yeah, this is the correct option. So first what we do is we get the PSAUX, right? And then we just remove the header, right? So the first line is the header. So we don't want that. So we can remove the header by using sed1d. And then we are sorting by the 10th field, right? So the 10th field is the time field. So here actually we don't need to like get the second and the 10th field. We can keep the entire line and we can just sort by the 10th field. So what does K10, 10 mean?
10, 10 means after 10 to okay. Sorry,
so the output of PSAUX is like this.
The 10th field is sorted on the 10th field.
Yes. So if we just have minus K10, it will sort on the 10th, 11th, 12th, etc. as many fields there are. If we give 10, 10, that means start sorting from the 10th field and stop sorting also in the 10th field. So it will sort only based on the 10th field. So based on the 10th field, it will sort each of them. So basically PSAUX, if you sort based on the 10, 10, and if you sort it with NR, right? So you get the highest one on top. So let me not have the R so that we have the highest one on bottom. So then you can see that this one is the one for 4431, right? So this is, okay, this is my browser. So obviously I should not kill it. So this browser is taking the like longest time it is alive. So if we are using sort K1010, we are sorting by the 10th field and we are getting the one with the highest CPU time at the end. So then what we are doing is we are removing all the ones that are like owned by root. So we can either do it later or we can do it earlier also. So we can do it after PSAUX, we can also do it after sed, and we can also, here what we're doing is we're doing it after sorting. So basically what we want is we want to just remove all those lines that are processes that are owned by root. Yeah. So now from those ones that are not owned by root and in the descending order of the CPU time, we take the first one, right? So head 1 will take the first one, and then so there we will have a lot of fields, right? So then we can use awk print 2 to get only the second field. So the second field, if you remember, is the process ID. So this is the second field. So if you're using awk, then we don't have to worry about the spaces, right? So even if there are multiple spaces, awk is smart enough to get the correct fields. So we can directly use awk to get the second field. And then this entire output of this entire thing, right? It will just print the PID that we are then passing into kill. So this is the command substitution. So this output of this thing, which prints the PID, is given to kill, and kill will just kill that process. So what is the difference in the first and the second one?
RN.
Other than that? Multiple things are wrong. So the first thing
head.
is, yeah, we have the head at first, right? So what will happen if we have the head at first?
We don't have other things.
Yeah, so we'll only have just one line, just the header line. So none of these makes any sense. So anyway, grep will not match, and sorting also will not do anything. And we just have one line that also we are removing. So we are doing sed1d. So in the end, output will have nothing. So it will not kill anything.
Yeah, even we are removing that line also.
Yeah, right. So nothing will be there. And the third option, so what is wrong here?
First line deleted. RN also the thing, and
yeah. So here we just have R. So we don't have N. So it is not sorted numerically. It is sorted alphabetically. Right. So that is not what we want. We want to sort it numerically. So we need a N here. So that's why this is incorrect. And the last one.
In the last.
The head can be. Okay, so the sed1d is wrong. So the sed1d should be done before the sorting. Right. So after sorting, if I remove the first line, that will remove the line that I actually want. So the first line after sorting will be the process that is consuming the most CPU time. So I don't want to
the second highest, basically. That's what it is doing.
Yeah. So then we will be getting the second highest CPU time. So that is not what we should do. We should remove the first line before sorting, which is the header line. So after removing the first line, then we sort and then we take the first line. So hopefully this is...
That head is not gonna be a problematic. It's in the very bottom.
No, so that is fine. Either, so if you have a lot of lines, if you take the first line, then you print the second column. Or if you print the second column of all the lines, then you take the first line. Both will be the same, right? So for example, if I have this, if I do head N1, so actually first line is always that. So yeah, let's see. If I do head N1, so here, okay, you can see this is one process, right? So if I do head N1, then I do awk print $2. So then I'm getting this PID 536. Or if I do awk $2, so this will print just the PID of all of them, but the order remains same, right? So then if I do head N1, I will still get that. So here you are selecting which column you want. Here you are selecting which row you want. So either way you do, you will get the same output.
Got it, sir.
So this is basically why this second option is the correct one. So coming up with the solution is harder than selecting which is the correct solution. If the solution is given, then it is easy to see, okay, this will be the way to do.
But still, there are little bit changes, sir. It's while doing the exam will confuse.
Yeah, so you'll have to basically see which thing done first and which thing done after that makes sense. Right, so for example, in this first one, you can see this makes no sense because at first only we are taking the only one line. So this will obviously be incorrect. And so in the third one, it is a bit tricky because there is just one letter missing. But then if you're comparing what is the difference, then you can see that, okay, here we have N and here we don't have N. Then if you remember, okay, what is N? Do we need it or not? Then you will realize, okay, yeah, we need to sort it numerically and not alphabetically. So obviously with N is correct and without N is incorrect. And similarly here you can see that, okay, after sorting, I am removing the first line. So you have to think basically what each command is trying to do. So sed1d is removing first line. So why should I remove the first line? I should only remove the first line if it is so usually it is the header. So I should only do it from the actual data and not the sorted data.
Got it.
So let's move to the next one. So here we have the following script are using various means to read a file into a script or a loop. Please select the incorrect statements from the option. So this is also sometimes we miss. So here we are asking the incorrect statements and not the correct statements. So we have case 1, while read line do echo line done data.txt. So we are running a while loop using the read command, and read command will read each line one by one, and the standard input is given by the data.txt. And for each line, we are simply printing back that line. In the second one, we are doing a cat data.txt and piping that into while read line do echo line done. Right? So here also we are giving the data.txt value as the standard in to this while loop. Here also we are giving the lines of data.txt into the standard input of this while loop. So in the third one, we are doing for line in cat data.txt echo line. So we saw something like this near the start of the paper. So what will this do?
Actually, sir, in the cat data, na, it will go line by line in for loop.
Yeah. No, so here we
something written in cat file, cat data.txt.
This will read word by word.
Word by word, right? So
word by one or line by line?
Because we don't have IFS, right? So by default, IFS will be white space. So it will split by word. So only if you have IFS to be the like $\n, then this will read line by line. So the third one is not correct. And in the fourth one, we have while IFS is colon, read -r, name, age, country, do echo name is name, age is age, country is country. Right. So basically, the data.txt is like a colon separated file which has 3 fields: name, age, country, and we are using read -r, name, age, country, to read 3 like variables directly in the like three fields in the 3 variables from each line.
From the data.txt, right? Sir?
Yes, from the data.txt. And in the fifth one, what we are doing is while IFS is nothing or blank, read -r line, do echo name is line, and then done data.txt. Right. So the first one and the second one are reading the lines correctly. The third one is going over word by word. The fourth one is also reading line by line, but we are also splitting that line based on the colons. Right? So if the line has 3 columns separated by colons, name, age, country, then we are getting them separately in 3 separate variables. And each line we are printing it like this: name is name, age is age, country is country. And in the last one, so what will be the output of this one? The last one, if we have IFS is empty.
So it will say.
So it will separate it by space.
Name, colon, and the whole line.
All right. So let's try this out.
China, the third one, in the fourth one, if you can just go back.
Yeah.
This one, will it store the each of the into the variable name, or name, age, country are the column names?
No, so they, those are the name of the variable.
By character actually, because
just hang on, just go ahead, please. Name, age, country is the column
name of the variables. No, the columns of the files can be anything. So ideally, hopefully, it is the same column. But yeah, these are the name of the variables. So what this will do is it will read 3 things, and the first thing it will store in name, second thing it will store in age, third thing it will store in country.
Okay. So whatever are the first 3 things it encounters after the colon, there could be any number, but it will just pick up the first 3.
Yes. So for example, if I have data.txt, so let's say this is name and then age and then country.
It's like key value pair searching for values by key.
So let's say we have these 3. So here I'm not going over the first 2 because they are simple. So in the third one, if we do for line in $cat data.txt,
without IFS.
Do echo line, done. So here you can see basically everything is printed as it is, but this is iterated 1 word at a time. So here, if I let's say do echo line colon and then this, so okay, yeah, you can see. Oh, all right, it is
writing, sir.
Okay, yeah, we actually here don't have any space, right? So that's why it is taking the entire thing. So for example, if this is, let's say, United States of America, in that case, if we run this, so you can see it is reading line by line, but as soon as there is a space, it's then treating that as the next iteration. Right, so this will work, but then only if there is no space in the data at all. Right, and now let's see the fourth one. So here what we are doing is we are doing while ifs equals colon, read, and then name, age, country. So we are taking 3 variables, and then do what we are doing is we are simply printing them again. We are doing name is name, age is age, and then country is country. So now if we do done and then we read it over data.txt, so then you can see name is coming. Okay, so actually I have comma separated. So let me make it colon separated. Yeah, my bad. So yeah, if we run this. So now you can see we have name is John, age is 21, country is India. Name is Jack, age is 22, country is USA. And name is Jill, age is 22, country is India. So it will basically read each thing separated by the colon one by one. And because we have 3 variables given here, so it will read 3 at a time and store them as name, age, and country. Then again, it will read the next 3 at a time and store it as name, age, country. Right, so that is, yeah.
What if we erase that variable age, colon age?
Okay, so if you remove
at the rate age, this,
yeah, this one, right?
Thing, here also, and the variable also. It will print only the name and country, right?
No, so it will basically take name and age, then it will take country and name, then it will take age and country, right? So it will be like this. Name is John, country is 21 colon India. Right? So it's taking this thing as the first one and the entire thing of the next line as the next one. So again, Jack is taken as name and the entire thing is taken as the next one.
Basically, the fields are separated in 3 parts, and we have to we have to give the variable name of those fields. If not, if we are not giving, it will automatically separating it by 2 only.
Yeah, yeah. So if you give 3 variables, it will separate 3 times. If you give only 2, it will only separate 2 times.
Got it.
Right. And in the last one, so what will be, so if we do while ifs equals nothing, read minus r line, do echo name colon dollar line, and then done less than data.txt. So what will this do if ifs is set like this?
It will default it will take default as white spaces.
Okay, so what will be the output?
The output would be, but the thing is in data.txt we have colon.
Yeah, we also have space here, like here, and here.
Okay, so the output would be first line, second line. The second line should be end at United. The third line should be okay.
Okay, so that is not the case, right? So if you have ifs to be like empty, so then it will not take space as the ifs, right? So here we, like if we set space as the ifs, if I give space, so then okay, why is it still okay? Yeah, if I set ifs, like if I don't set ifs at all, so then we saw that it is taking the okay, why is this? Okay, I think we did not have the minus r that time. Okay, we were getting one where we were like getting it in separate lines, right? Okay, so that was in the for loop. Yeah, sorry. So in the for loop, if we are changing the ifs, then it will affect the for loop. Right? So for example, in this, instead of this, if I set ifs to be something else, so if I set the ifs to be the colon symbol, then one second. I have to put a semicolon here. So then you can see it is splitting by the colon, right? So it's taking John, then 21, then India. And then it's taking India and Jack together, because after India and before Jack, we don't have a colon. So it's taking India, new line, and Jack together. And
colon
similarly,
is no separate.
Yeah, so colon is separated. So changing the value of ifs is affected only in the for loop, right? But if we are doing it in the while loop, so whether we give the IFS or whether we not give the IFS, so it will not make any difference. So for example, if I set the IFS to be colon here, so then the read line will split by colon and it will take like 3 things. So for example, if I give line and then X and Y, so it will only take the name to be in the line and the age to be in X and the country to be in Y. So here if we print X and Y also, it will also be printed. So $X and $Y. Yeah, but the read itself will read it line by line. So even if I don't put these, and so then the other things are not taken, the entire thing is taken in line. And then if the IFS is colon or if it is set as nothing, then it will not affect it. Because we're only having one variable. So if we have only one variable, then whatever is the value of IFS, it will read the entire line in that variable.
So it's correct or not?
So yeah, it is reading the entire thing and it is printing it at name. So it's obviously not the name, it will be the entire line. So it is printing name colon then the entire line. So let's see the options now. So the option is case 1 uses input redirection method to read the file line by line. So case
what is
1,
the question? Incorrect, okay.
Yeah, please select the incorrect statements. So the first one, case 1 uses input redirection method to read the file line by line. So here, as you can see, it is really using the input redirection, right? So the input instead of standard in is sent from the file. So this is a correct statement about the first case. So because we have to select the incorrect statement, so we don't select this one. So next, second one is case 2 uses the pipe redirection to feed the cat output to the while loop, which is also true. So cat data.txt will print and then pipe is used to give its output to the while loop. So this is also correct statement. So we don't select this one.
That I didn't knew earlier.
Which one?
That second option, but I got it now.
Yeah, so we are using pipe here, right? So like instead of giving standard in from a file, I can also give any other standard in. So I can run any command and pipe that output to the while read line. So not just cat, I can give anything like output of ls also, I can pipe it into while read line. And it will read it line by line. Right, so that's
why. Take it as a standard input.
Yeah.
Got it.
Right, so the third option is the pipe redirection used in case 2 is inefficient compared to the input redirection. So why is this the case? Why is the pipe redirection inefficient?
What was the mistake in that?
So there's nothing wrong. Both will print it correctly, but this will take a little bit more time. So why is that?
Sorry, sir, what you're asking?
So basically, the third option is the pipe redirection used in case 2.
You're looking at second option.
No, second option we did, right? So case 2.
In the third option you are saying.
Yeah.
I was looking at third case.
Okay, yeah, no. So in the second case and the first case, so the output is same, but the second case takes more time than the first case. So why is that?
Because first it will read the data.txt, then it will then it will take the input.
Yeah, so in the first one, bash is directly giving the input line by line. Whereas in the second one, first bash is calling the cat command. Cat command is printing the output and then that is being redirected, right? So we have an extra command that is being run here. So the output, although it is same, the second command takes a few milliseconds more time. So this is inefficient. So if you just want to give the contents of a file to some command, you don't have to actually cat it to that. You can directly use the redirection. So that's why the second one is inefficient compared to the first one. Right, so the fourth option is case 3 uses command substitution with the for loop to read a file. So that is also correct. So in case 3, we are using command substitution, right? So if we have the cat data.txt, which is a command, and we are first running that command, and on the output of that, we are then running the for loop. Right? So it is using command substitution and a for loop to iterate over the file line by line. Sorry, word by word. So case 3 uses command substitution with the for loop to read the file. This is also, yeah.
So in the case 3, like it is taking word by word. Can we take line by line also?
Yeah, if we set the IFS to be the $\m, right? So then it will work. So for example,
No, so like in for loop can't anything the thing that we can that will specify the line that we want on the line only, or
no,
we should
in
use
for
the
loop,
IFS only.
yeah, in for loop you cannot directly specify. You have to use the IFS. So here you can see that. Yeah, so if I use for line in cat data, do echo line. Okay, I forgot to reset the IFS, right? So the IFS is still set at the colon. Right, so now you can see, so if the IFS is, which is by default set as space, so then you will get the lines correctly, but if there is a space, then you will split by the space. But if you want to read line by line, you can either set the IFS to be empty, so then it will take line by line, or you can set the IFS to be dollar and then quotation \n. So then also you will get it line by line.
Got it.
So let's see the next one. So the next option is case 4 is input redirection, which reads each entry in the data.txt file, assuming the file has 3 columns into individual variables. Right, so that is what the case 4 is doing. So it will read line by line, but then each line it will split into the 3 columns. So name, age, and country, and it will store it in the 3 different variables. So that is what the fifth option is stating, that case 4 is input redirection. So that is here also we are using the less than symbol. So it's input redirection, which reads each entry in data.txt file, assuming the file has 3 columns into individual variables in the name, age, and country variable. And this option is case 5 reads the entire line of the data file and assign it into the line variable. So in case 5, as we saw, because we are using read with a single variable, the value of IFS does not matter, right? So even if the value of IFS is set to be nothing, still it is reading line by line only, because we are using the read command with just a single variable. So this is also correct. Case 5 reads the entire line and assign it to the line variable. So the last option is none of the options are correct, which is obviously incorrect. That's why we are selecting that option. Right, so hopefully this is clear. So let's move to the next one. So here we have choose the sed script that converts each line of the input file to an element in the JSON object. So the input file contains 2 words per line. The first word is the key and the second word is the value. So output should be a valid JSON object of key value pairs. So for example, we have something like this: fruit 1 apple, fruit 2 banana, fruit 3 orange. And we should print it this way. So we should say like in a JSON format. So the key should be surrounded by quotations, the value should be surrounded by quotations, and in between them we should have a colon. And at the end we should have a comma. So let's try to implement this. So if we have a data where we have fruit 1 apple, fruit 2 banana, and fruit 3 orange. So now we have to basically write a sed script. So we cannot use any bash, we can only use sed in this. So let me also create a script.sed. So now what substitutions can we do so that this turns into something like this? So this opening curly brackets and then quotation fruit. So let me just copy this. So all of these should be quoted and the comma should become a colon. And in the end, we should have a comma. So the last one should not have a comma because in JSON, a trailing comma is not supported. And in the end, we should then have a closing curly braces. So how should we do this in sed? What are the substitutions?
Sorry, what you are doing in this question, could you please show?
So the question is, given this input, how do we get this output using a sed script?
Basically, we want to change the pattern of printing.
Yeah.
It's like
So
key value pair.
Yeah.
Okay. Sed.
the output file should start with a brace and end with a brace. Okay.
Yes. Yeah.
So let's that's there. Okay.
First yeah, go ahead.
Sapnaji, you go ahead. No worries.
Okay. So what is the most obvious substitution in this?
Replace comma with a colon.
Yes. Right. So we can substitute a comma. We can substitute it with a colon, or we can maybe substitute with a quotes and a colon also. That is also fine. Right. So each line, so this comma should become a colon. So let's see each step of the way. What is our output? Right. So now we have this. So now we have to add the. Sorry, let me actually add the quotation here also. That is the expected output.
So, sir, we can write that colon, that double quotes, colon, yeah, like that.
Yeah. So now we will have the quotation on both the places. So how do I now add the quotation at the start of the line and at the end?
Start of the
Cap.
The cap
Dollar.
Yes.
Yes.
Cap dollar. Yeah.
And same for the dollar, right?
Yeah.
Yeah. So these will now add the quotations at the left and right of the line. So now only thing left is adding the opening and the closing, and also the comma. So how do we do that?
No, for the comma, right? The dollar, say S dollar can be replaced with S quote, right? Line number 5.
Yeah.
Replace it with this one. Yeah, dollar with this one. Yeah, comma.
I can just add the comma here, right?
Yeah.
But the issue with that is it will also add comma in the last line. Whereas last line we should not have that.
Complex, sir. I'm not gonna.
Okay,
so wait, let's do this, and then now let's insert the first in the first line. Let's create a new entry for our open braces.
Yeah, how do we do that?
I think there is a I in flag or something like that.
Yes.
Here.
Yes. So if I do I and this, so this will add a opening brace on before all the lines. So how do I ask it to add only before the first?
I1.
Is it I1 or one I?
One I. Yeah. One I. Sure.
Yeah. Right. So first we give the line on which to act, and then the action. So now we have this at the first. Similarly, how do we add this one?
A1A.
Is it?
Sorry, dollar A.
Dollar A, right? So dollar means the last line. A means append, and then we are adding this closing. So now almost everything is done. So now we should be also able to add the comma. So how do I add comma on all lines except the last line? Yeah.
And, last line will be
Okay, so what is the line on which I don't want a comma?
Third line.
NR minus 1.
No. So assume that we have not done this. So
it will be NR.
Last line, right? So how do we access the last line? The dollar, right? So NR is in yeah. So here we use dollar. So in dollar, we don't want to do something. So if you want to negate an action, we use the exclamation mark. Right. So then basically it's ChatGPT has actually figured it out. So what we say is on all lines except the last line, substitute the end of line with a comma. So we are also adding comma at the end of line, but we are doing it on all lines except the last line. Right. So now this will add the comma on all lines except the last line. Then we can what we were doing earlier. So we can add that. So this is how we So this is how we should do this. So now we can see the output is the expected output.
Sorry, share the dollar negation. Then you're substituting dollar with.
So dollar means the end of line.
Oh, okay. That also takes it. Okay. Sure.
Yeah. So same as how we did in this.
Yeah, correct.
Yeah. So first we have added the quotation, and then only for some lines, we are also adding the comma at the end.
Sir,
So yeah.
This can be done this way also. In line number 3, we can go for S dollar comma line number 2 here, relative line number 1, 2, 3, 3 lines below where we are replacing dollar. Yeah, add a comma over there. Yeah, and then in dollar.
Yeah.
Okay, just in dollar, replace S with replace comma with not this one, comma dollar with just dollar.
Yes, this is also correct. So add comma everywhere. Then in the last line you remove the comma. That is also correct. You can either do this way or you can do this way. And hopefully this is clear, both the options.
Sir,
yeah.
Could you please explain those last 2 lines?
These two?
Yeah.
So I is a command that inserts a line before the line, and we're simply inserting the curly brace symbol. So I don't want to insert before every line, right? I don't want to insert before line 2, line 3. I only want to insert before the first line. So 1 is the first line. Insert before that line this symbol. So I'm inserting this curly brace before the first line. Similarly, A is a command that appends something after a line. So if I don't give the dollar, it will append that after all lines. I don't want to append after all lines. I want to append only after the last line. So only after last line, append the closing curly brace.
Got it.
Right. Okay. So let's see.
I got it if this is present in the option.
Yeah,
I'm gonna confuse it.
So okay, let us see what are the options. Okay, so the options are more confusing than what we have done. Right? So this looks easier to see than this.
That is fine. That is we are familiar with.
Yeah. So like the first and last one is what we have done. So one I brace and $A brace. So we are adding the first and the last one. Then we are doing basically 2 things. So this is what we're doing only in the last line, $, and this is what we're doing in all lines other than the last line, so $not. So on all other lines, we are substituting anything that starts with, and then we are grouping the first thing, like the key, and then a comma, and then the second thing, which is a value, and then the end of line. And we are substituting that with quotation and then group 1. Right? So the key we are quoting, colon, and then the value we are quoting, and then we are putting a comma at the end. And same thing as the previous line we are doing, but we are not adding the comma at the end for the last line. So for all lines except the last line, we do this substitution, and for the last line, we do this substitution. Right? So maybe this is easier to understand, or maybe this is easier for you. So either way, we can do it both ways. So the one I and the $A will add the opening and closing. And then for each non-last line, we have to do one kind of substitution where we add the quotation to the left and right, and we add the colon instead of comma in between. And we also add a comma at the end for all the lines other than the last line. And in the last line, we do the same thing, but we don't add the comma.
So what's that after substituting? What's that why we are doing this dot star again and again?
So dot star means any character any number of times. So we are searching for any character any number of times followed by comma, and then any character any number of times. Right. So the key is matched by the first dot star, and the value is matched by the second dot star, and in between them we have the comma. Okay. So then we group the key and we group the value using the round brackets. Right. So we are grouping that so that in the replacement we can again refer back to it.
Got it.
Right. Okay. So let's move on. So this is the next question. The files file1 and file2 are present in the current working directory, with file1 composed of 4 lines. How many lines does file2 have? So here this is a diff question. So here it is telling that file1 has 4 lines, and then we have diffed file1 and file2. So it is telling that in file1 we have MNOP, whereas in file2 we have MNPO and QRST. Right. So in file1 instead of MNOP, in file2 we have MNPO and QRST. then what is the, and obviously then other lines are same. So if there is some line not shown on diff, that means that line is same as the other file. So only in the fourth line, we have, instead of MNOP, we have MNPO and QRST. So then what is the number of lines in file 2?
More than 5? No, 5.
5, right? Yes, because the first 3 lines are exactly the same. And the fourth line, here it is MNOP, and in the fourth line on the file 2, we have MNPO, and then again we have another line QRST. So we have total of 5 lines, out of which 3 are common. So the answer is 5 here.
Sir, could you please scroll up, because it's end of, this is the last question.
Yeah.
Sir, could you please show the above question?
Okay, this said one, right?
Sir, I want to see the options.
Yeah.
The other options. Like, could you please? Like,
yeah, these are the first and second option.
The first option itself is saying it is like the orange is also having the comma, right?
Yeah, yeah. We are adding, no, here what we are doing is, we are only for the last line we are doing the substitution. So all other lines we are not substituting at all.
Only for the last line, how?
Because we have a dollar here, right? We don't have dollar exclamation.
Okay.
Yeah.
Okay. What is the difference in second line, second option?
Okay, let me see. In the second and in the third one, okay, the quotation is not correct, right? So it is quoting the entire line, whereas the key and the value should be separately quoted. It should be quoted key colon quoted value, and not quotation key value quotation. And everything else is the same.
Okay, got it. Yeah. I just saw the first and second option.
Yeah, the first one. Okay, so if I zoom out, maybe. Yeah.
The thing is like the quotation particularly thing.
Yeah. So here the quotation is correct, but then this is wrong, and here quotation is wrong. Everything else is correct. And the third one, everything is correct. And in fourth one again, so quotation is correct, but we are only doing for the last line. So we are not doing for all other lines. So hopefully this is clear. Just let me know if the diff question is clear, or if there is any doubts in this.
That is, last one is clear for me.
Okay, all right. So most probably we won't be able to do the other paper because it is already 10 p.m. So just let me know if there is any doubts in any question in this paper itself.
Sir, this question paper is available in your in the website you have given, no?
No, it is there in the sheet. Yeah, it is there in the resource sheet. Yeah, you can see it is here. You can get it from this.
Here also. I'm not sure.
Yeah.
Okay.
Just let me know if there is any other question which is confusing. Otherwise, we can end today's session. I'll stop sharing.
There is no more.